Okay, guys, so welcome to Zero to Hero Security class again. This is meeting number 6. Let me share my whiteboard real quick. Oh, here we go. Week 6, and today we're going to continue talking about AMP. Then we go to the IPS, a big topic, and preprocessors. And finally, we spend some time on SSL decryption. And if time allows us, I will go through the alerting and something called a correlation policy. Okay, so that's the plan for today. Let me adjust all the windows I have here. Right, okay. So last week I was talking about this actually, which is the AMP, how AMP works. Okay, I still need to open chat and see you. Okay, cool. So how this chat is, or how this the AMP works, and this is about AMP for networks, which is the AMP connector working on a networking device, like FTD, for example, in our case. But we also have AMP for endpoints possible to install and configure a connector to the cloud, AMP connector to the cloud on the endpoint. Right? Both are using the same cloud or utilizing the same resources in the cloud. The only difference is where we have them installed or running. And also there are some small differences between the features that they can use. So for example, ethos, the engine, is not available on AMP for networks, but it's available on AMP for endpoints, right? So there are some differences here. Okay, so let me show you the configuration part of AMP, how to configure it. Okay, to open a connection to my lab. Okay, I'm logging into the firepower system. And under the policies, we have something called a malware and file policy. By default, we don't have any policy there. but we can create a new one. I'm going to create a new policy, call it my file policy. Then I'm going to configure a couple of rules here, examples. So I'm going to create a rule, first rule, without that is not going to use any AMP connector. It's just going to be using the file detection capability on Firepower. So for example, the rule will be working on application protocol HTTP in the direction of upload. So for example, I would like to detect and block any tries that my user tries to send some Office files out of my network, right? Upload them to the internet. So I can check the category, the whole category for Office documents. You can see that there are 18 different file types. There's a new Office format, an old Office file format, and also RTFs and so on. So there are a couple of file types in that category. I can also, instead of using the whole category, I can select only individual file types if I want to. But I will use, in this case, the whole category of Office documents. I don't want my users to send them out, so I'm going to block. I will change the action to block files. And so this configuration I'm showing you here is not utilizing AMP at all. It doesn't require you to have malware license. It works without malware license. This is just the file detection capability on a Firepower. Okay? And I can reset the connection if something like this is happening. I can also store files locally on the Firepower to see what files my users trying to send out. So that's the one of possibilities. Another rule, I will also use it for HTTP, but this time for a download, so for direction. And I don't want my users to download from a multimedia category MP3 files. So I select MP3, and just MP3 file will be blocked. Obviously, I need to change that action to block files. The action detect files is just detecting, logging, but it's not doing anything. It's just allowing the file to go through. But blocking files is just sending the reset to reset the connection back to the user. Another rule, those two rules I just created are using just for blocking files. Now let's take a look at the AMP anti-malware. So again, I will choose HTTP or FTP. I would not leave this option as any, because for a simple reason. Let's see, for example, one of those possibilities here on that list is the SMTP, which is the mail. If a mail with malware attachment is going through the FTD, there can be a malware attachment, deleted, but also the whole packet and the whole email can be deleted. Okay, so I don't want to do that on a Firepower. I would rather do those things on some dedicated system like email security appliance, right? The system is there to detect what's going on. It can send a message to the user, can quarantine the original message, send the message to the user that there is a message for you waiting in the quarantine. all those things you can manage, but with this option, we are just seeing a packet, and we see the file in the packet or packets, and if we decide based on a file detection capability and the malware anti-malware detection, if this is the malware, we can just get rid of the whole connection, the whole file, and the whole email even. So nobody gives you or ensure you that this is gonna work for SMTP. That's why I would like to be very yeah, I don't want you guys to basically to use this any, because that might be too dangerous. So from that list of possibilities, I would just use HTTP and FTP. Even for the SMB, that's possible. If, for example, if you have your firepower in your inside network, and you don't want, maybe I don't want to try to go through or spread over to different machines, then the SMB is okay. But that might be also quite overwhelming for the system. There are some limits though, so do not think that every file will be checked this way, because that's not true. There are some limits based on the file size. So too small files are not being checked. Too big files are not being checked either. Yeah, definitely. Because remember, the file, to calculate hash of that file, the file must be stored, must be buffered. So that's gonna take time and resources on the system. So to be honest, I would just go for HTTP and FTP in that way, in that situation, not using any other. Definitely not leave it as any. Okay, so another option would be like this: application protocol is HTTP, direction of transfer is any, because I don't want to send malware out. I would like not to get the malware from the internet either. So any is okay for a direction. Then I can select either executables, or I have a specially created category here called dynamic analysis capable. Okay, so Microsoft executable, Office files, PDFs, those kind of files can be sent to the dynamic analysis, but can also be checked for AMP. Okay, so I select this category, and for action, I use block malware. By the way, the malware cloud lookup is just like detect files for file detection. It's just checking if that's malware, and doesn't really it doesn't depend on the malware disposition. The file will be allowed anyway. So I don't think this is any useful. But the block malware is the way to go, right? So if you select block malware, this action will actually enable checking the file in the cloud based on its hash, SHA-256. Okay, remember, the disposition check by default is sending the hash. So FTD will calculate the hash of that file, send it to the FMC, and FMC will take a look in the cloud for a disposition of that file. So this action, block malware, will check this hash only. But you can also select some other options here, like I would like to also include Spiro engine file fingerprint. Remember those attributes for Microsoft executable files? We can also add this fingerprint to the query. Yes, this feature, yes, to have that action, you must have malware license for it. Yes, exactly. Right. You can also select dynamic analysis, which is the sandboxing. Right. If you check the dynamic analysis, you have option to send the file, by the way, directly from the FTD. So the file is no longer sent to the FMC and the FMC is sending it out. No, this is a FTD through its management interface is reaching out to the AMP cloud, sending this file, the file itself, to the AMP cloud. The AMP cloud has this API connection with a thread grid, with the sandbox, right? So can send it to the sandbox and you know, for additional analysis. But remember, this is not going to happen in less than 200 milliseconds. It's going to happen in maybe 10 minutes or more. So you can just send it, but you will not rely on any feedback from the thread grid, unless the thread grid already know that file. Then that's going to be quick, and the thread grid can give you some additional information. Then notice that when I selected the dynamic analysis option, there is another checkbox active, which is a capacity handling. This is about attempting to store the file, because this way, if you're sending the file itself to the thread grid this way, there is a limit of 100 submissions a day, right? The question in the chat, so for those 10 minutes, the malware can spread. The malware can, yes, can make that the host, you know, the infection, the initial infection. But remember, the initial infection is not yet, you know, anything, you know, it's not the end of the world, because this malware must go out to connect to the CNC and so on. So there are a lot of other steps that the malware must take in order to do something, really. So initial infection is not the end of the world yet. Yes, but for those 10 minutes or so, if there is some, you know, serious information from the thread grid, yes, we are vulnerable. Right. So back to the capacity handling. I said there is a limit. This way, if you're sending your file to the thread grid, there is a limit of 100 submissions per day. Right. If you cross that limit, you need to wait for another day to reset the limit. But the capacity handling can buffer files for you. Okay, can buffer those files and send them when the limit is available again. Okay, but obviously if you have a lot of files going through the FTD and you're checking for all of them, you're sending all of them to the sandbox, this capacity handling may not help you. But there is there are two solutions for that. Solution number one is to have your own thread grid account, and the thread grid can be bought as a product two ways. It can be a software as a service, so cloud-based product, or it can be a local appliance, right? So depending on what you have, you can configure Firepower, FTD and FMC to reach out to your thread grid account. So you're no longer utilizing the AMP cloud to go to the thread grid through the APIs, because that's limited to 100 submissions per day. But you can use your own thread grid product if you buy it as a separate product, and then you can connect FTD and FMC to talk to the thread grid directly, and there is no limit in that case. I will give you all those possibilities in a second on the slide, okay, on the drawing. Also, something called local malware analysis is possible, and I think this is a really good idea, because local malware analysis is just a couple of specially crafted signatures that are created for malware. Those are the CLAM AV signatures that are running on the FTD itself. So you can use those to catch a well-known malware quickly. And if you catch malware this way, the dynamic analysis, even if it's enabled, will not be used. So that means if the local malware analysis is enabled, that's going to be the first step. If we catch the malware this way, the file will not be sent to the sandbox, right? So that's another optimization capability here. So I think the local malware analysis is something that should be checked here. And there is a connection. So that's the last option. And also we can store files based on their disposition from the cloud. As I said, we have 3 dispositions: malware, clean, or unknown, right? So I can, based on the disposition, I can have those files stored. For example, if I select malware, the malware disposition for files with a malware disposition will be stored on the FTD. So I can download them and use some maybe investigation, some reassembly, reverse engineering of the code, things like that. If I would like to do some further investigation on that, I can use this option. But notice there is also number 4, a custom. A custom disposition is when you create your own kind of blacklist of files. Yeah, obviously that's a real malware that you catch, okay? So, but by the way, the file is not just stored on a disk, it's automatically archived as a zip file and password protected. The password is infected, by the way. So you can download it as a zip file and do some further investigation, or if you like, you can send it to your friends, which will probably not be your friends anymore. Yeah, so back to the custom. So the custom category or custom disposition, in this case, is you can create a file list. This is basically a list of hashes that you would like to treat as a malware. Okay, so you can create your own kind of blacklist for files, if you wish. And then, based on this disposition, which is obviously the local decision on the FMC, you're going to have a custom disposition, and you can also catch this. Right, so I think this is a good thing. I would also add another rule here, because unfortunately we cannot select 2 application protocols from that list. So I would like to use the same for FTP. All right, so for FTP, block malware, select dynamic analysis capable, add that, right? And also maybe not sending that to the dynamic analysis, but just using Spiro and hash. Notice that there is a warning here in my policy, because this policy is not like a typical firewall policy. It's not being checked top-down first match. It's basically based on the file types. So warning is here because, as you hover your mouse on that, it will tell you this rule will block malware lookups on Office files, right, for the rule matched with warning 2. So basically, we have a category Office documents here over HTTP and upload. And here we are doing a cloud lookup, which is the malware protection, also for files that are included here for some Office files. Okay, so if we're blocking the Office files in the rule number 1 at the top, it will not be able to do the malware analysis on those files. That's obvious, right? But notice the direction, right? This is the direction for upload here, so that's not a big deal. We're going to be blocking Office files that are being uploaded, but for those downloaded, the anti-malware will still work. So that's the thing. Let me show you the file. Let's get back for a second. On the Advanced tab, we have Enable Clean List and the Custom Detection List, those two checkboxes. If I go to the objects, because the Clean List and the Custom Detection List is an object, similar to the Security Intelligence, right? Those blacklists are objects. So here we have file list category here, and we have a clean list and the custom detection list. I don't know what this name is like that. I would change it to something like a file blacklist, file whitelist. So the clean list is the whitelist, the custom detection list is the blacklist. So I can edit that and add a hash on that list. I can add a list of hashes, I can calculate hash, or just enter a value here of that hash. And so the easiest way is to, for example, to calculate. Then you can browse for a file. Some people are using this option to block, maybe to not to not block or to do the anti-malware, but to block some files from being downloaded from the internet. Like an example might be, I have a PATI. So I will add PATI on that list, PATI's hash on that list. Right, so this hash from now on gonna be treated as a malware. Okay, so I may create a file policy if someone is downloading this file, and we should block it, right? Or treat it as a malware. Okay, that's a good question, Quais, in the chat. Can you link upload document policy with certain users, or it will be generic policy? You can, but that would require you to create an identity policy, because remember, once you have that file policy configured, okay, let me go through this here. File inspection is also here. Let me finish that. Okay, so if you want to inspect also archives, you need to check this box, this option. But remember, once you have that policy created, you need to go to the access control policy and apply it to some rule. So if you create a rule for your specific users and apply that policy only for that rule, that's going to be working the way you want it. Right? So for example, if you add a rule here, and you can use users, but that would require identity policy to authenticate users somehow, right? Then you can apply only some policy, some file policy only for those users. Right, so remember this, number one, web allow, right? Destination port HTTP, the action is allow. I can click this files icon. That's gonna give me, take me to the inspection tab. And here I have a file policy. I can select my file policy and click save. Okay. So that's the way how we can apply the file policy to a rule. Okay, then I can save and deploy my policy. Let me deploy it and we'll see if that works. Okay, so the file policy. Notice that sometimes you can see that this inspection interruption is set, say yes. Okay, also you have this yellow message at the top. This usually happens when you for the first time applying some policy like the file policy. That will require a snort process to be restarted, and that's going to take a couple of seconds or milliseconds. And some of packets that are going through the device at this time may not be inspected or might even be dropped. Okay, so you need to be careful. If you see when you click deploy and you see the inspect interruption set to yes, you better do this deployment in the maintenance window or outside of the business hours, at least. Okay, let's deploy that file policy. And in the meantime, I will go to the advanced tab because we have a couple of options here for file and malware as well. Here at the bottom, we have the section files and malware settings. And notice that there is a limit of bytes inspected to do the file detection, file type detection. It is set to, by default, to 1460, which is the whole payload of a file. That's usually okay. Then we have allow file if cloud lookup for block malware takes longer than 2 seconds. So if for some reason, if the FMC is asking the AMP cloud for a disposition, it takes more than 2 seconds, okay, we can allow the file. So we are not blocking this. Remember, it should be less than 200 milliseconds. So if it takes more than 2 seconds, it might not be, it might be a fault of something in between, okay, the FMC and the cloud. Also, there is an option to not calculate hash for files larger than, and this is the default limit. Notice this is the 10 megs. Okay, so this is the 10 megabytes. So bigger files are not basically being checked. You can change this, but that's a pretty conservative number. 10 megs, it's still okay. Because remember, if it comes to the initial infection, when a dropper, came down or coming down, this is usually a small piece of code. It's not 10 megs. Do you leave these settings alone for production? Yes, I would, yeah. Unless you have some corner cases or specific requirements. Like you know that you would like to find out if there is a malware in your SMB in a file transfer, and you know that you have files larger than 10 meg, and you would like to check them as well. So then I would change this value, but you need to be very careful about that because that may overwhelm the system. Okay. There is also a limit for storage of files set to 1 meg. So if you have, if you find malware in the 2 meg file, and you have that option to store based on the malware disposition, this file will not be stored because the limit is by default set to 1 meg. Okay, and also what files, in case of size, in terms of size, we are sending to the sandbox. Okay, it's also 1 meg, the default limit. Okay, how about my deployment? Okay, it's done. Let's check out. I'm going to use my employee PC. Yeah, so FTP policy will not be triggered, but if I have FTP related rule in the access control policy, then I can apply the same file policy to it. Okay, so I have only my file policy applied to the HTTP traffic, right? So obviously those rules for FTP that I have inside the file policy will not work in this case. But if I have another rule for FTP, I can apply the same file policy to both. I will try to download some malware. I'm hosting some test files. Okay, it's files 2, I believe. Let me check. Is Firefox fully running? Okay, so it's showing me to save the file, the window to save the file, but even if I try to save it, it is not going to work because it says that the file is broken. Okay, I have two Firefoxes opened. All right, so now based on that, I should have a log or event in the analysis file malware events. Okay, here we go. See, this is a file that I was trying to download. This is the file hash type, right? And I can also click this red icon next to the file hash to see something called a network trajectory. So the network trajectory is a nice feature that can give us the information or insight what was the patient 0, what was the first seen, or where this malware was first seen, when, and on what host. Okay, some more information like file size, type, current disposition. Notice that the name current, right? The word current. That means the disposition can change, right? So we can even edit that and add this to the clean list if you don't want this file to be considered as a malware anymore. We have a threat score as well, so there are some information from the threat grid. The threat score for that file is very high, which is bad. I can click this icon next to the very high label to see the threat grid report if available. Okay, actually not this time. Also see all the events. If multiple computers in my network would download that file, I see all those events, individual events on the table. I can also see how this file was injected. So I see that the file was injected by the client Firefox. So someone downloaded this directly with a Firefox. Okay, so that's a really nice feature that's showing us a lot of useful information of that file. And obviously, file was blocked because we saw that in the file malware events. I can go deeper and see that event. If you click that down arrow next to the event, you will go deeper into the table view of those individual events, and the action is here, malware block. Okay. But also I think I have some other files there. Well, let me check real quick because I'm not sure how the file is, what the file name is. Right. Okay. File. The next thing the next option, or actually a rule in the file policy, was to block, not the anti-malware rule, but the file detection rule. It was to block MP3. I have file MP3. It looks like it's opening, but it will not be able to open it because of the file blocking. So that should be, this event, it should be in the file events. Because that's not the malware. It's not a malware disposition for a file. It was just a detection of the file. So I see multimedia category, MP3, action block. Actually, file summary is showing me the malware as well, because the malware events is a subset of file events. Right? The file event is about all files, but malware events is only for those files with a malware disposition. So action was block, right? File name was file MP3, type is MP3, category multimedia. Okay. Let's check, because I have the same file, the same MP3 file, but with a different extension, file extension. So we can check if that's still working, the file detection. If I change the file.tst, right? There's an error that the MIME is incorrect, file tst. If I refresh this log, there should be another block entry here, but this time it should be a different file name, but still the same file type. See this? The file name was file.tst, but the file type is still MP3. Okay, so this detection is not based on the file extension, it's based on the file magic. So it's checking the content of the file. I also have file exe tst. Let me check if that works. For example, if you're, someone in your network is getting a file that looks like an invoice.pdf.exe or something like that, right? This is not possible to download. Even if I try to save it, it will not be able to save it. It's saving it, but it's saying that there is an error in saving the file. And this time it shouldn't be the file event, because that was the malware event, but it should be in the file events anyway. Let's go to the malware events to check for that one. Notice this, that this is still the same malware. The file name is completely different, but the hash is still the same. And this is the Microsoft executable file. Right, so that works pretty well. Right, you can configure the integration between your FMC and the AMP cloud here in the AMP option. There are two options here, sub-options: AMP management and dynamic analysis connections. One is connection to the AMP cloud. Another one is the connection to the thread grid. Okay, if you go to the AMP cloud, by default, the system is configured to point to the public cloud in the US. See, the cloud name is the US cloud. It's for AMP for networks. But you can change that. If you are in Europe, for example, you would like to change the cloud to utilize the Europe cloud instead of US. So that's obviously a very good choice. If you are in Europe, you can change to EU cloud. If you are in Asia, you can change to Asia Pacific cloud. Okay. Also, you can click and add AMP cloud connection because you may use something called a private cloud. So notice that there is an option to create a private cloud connection. Then you need to specify the host where the private cloud is. I will be talking about the private cloud and AMP for endpoints later in this class. So not now. Now we're just focusing on the AMP for networks. Okay. But if you have a private cloud, you can point to the private cloud instead of to the public cloud. Do you know where in Asia it is hosted? I don't know. I'm not sure where. I would say that it might be Singapore or something like that, but I don't know, to be honest. I know that EU cloud is in Amsterdam, but where the Asia cloud is, I don't know. Maybe some guys know that better than me. Okay, so that's the AMP connection and the dynamic analysis connection. So the sandbox or thread grid, by default, it's pointing to the thread grid.com, to the public cloud thread grid system or software as a service, right? And you can add new connection if you have your own thread grid appliance. Then you can specify an appliance host IP and the certificate for authentication, and you can configure it with your local appliance. Right. Then, and a lot of people actually, I know that they are using local appliances, thread grid appliances, because they usually don't want their files to be sent out to the public thread grid. They would like to have them locally sandboxed. So that's why most people are utilizing the sandbox locally. Right, so I can give you those options here. 6.1. For AMP, or maybe FTD. FTD plus AMP plus thread grid. There can be a couple of options to do that. You have FTD, FNC, and by default, you're utilizing AMP Cloud and the thread grid cloud here, right? FNC is sending disposition check to the AMP. FTD is sending the dynamic analysis to the thread grid cloud. Right? That's the default. Okay. Obviously, the malware license is required to do that. Okay. But there are limits. Remember, limits up to 100 submissions per day. Okay, but still, I would say 95% of customers are using this. Okay, option number 2, what you can do here is this. You have your FTD, FMC, and you are using still AMP public cloud, okay, but for, okay, so this is not, for file submissions, you use thread grid appliance. Okay, that's option number 2. Option number 3, and here you have no limit because you're using your appliance, so you don't have 100 submissions per day limit anymore. And option number 3 is this. You have FMC that is not connected to the public cloud. It's talking to something called the private cloud. It's actually a VM. Okay, it doesn't need to be because there's also possibility to buy it as an appliance now. So private cloud, and the private cloud talks to the public cloud. Okay, or because there are 2 options to deploy the private cloud with. There's a proxy mode and air gap mode. In the proxy mode, the private cloud works like a proxy, excuse me, to the public cloud. Okay, so your hash, if you're asking for this position or this hash, you are asking the private cloud. Here, you are asking the public cloud directly. Here, you're asking private cloud. And also, all events are being stored here. Okay, so you have your events locally, and the proxy mode of deployment, this is going to be kind of anonymized. Okay, so your events are still local, stored locally, and this query is being anonymized. So the AMP public cloud is not seeing any, any things like a username maybe if it comes to the AMP for endpoints, because on the AMP for endpoints, it can also talk, right, to this private cloud. Right, and hash sent here. Right, so in this case, if you are sending or doing the disposition check from the AMP for endpoints, you're gonna send some more information like username or file name, file path, and all that stuff. So this query gonna be anonymized by the private cloud and sent to the public cloud without such, information like sensitive information like a username. What is the added value of the private cloud? In my opinion, this is the most important thing. If you want to store your events related to the AMP, anti-malware locally, there is no other way to do that, to keep them locally. Okay, because even if you buy your public cloud, as a service, then all your events will be in the public cloud, stored somewhere that you don't have a control of, right? Who offers such a service? You can buy it from Cisco. Okay, so you can buy the access to the public cloud directly, or you can buy private cloud VM. Okay, if you have a public cloud, all events will be stored in the cloud. If you have private cloud, all events will be stored on the private cloud locally on your network. Yes, it is also an appliance. Yeah, it can be either a virtual machine or an appliance. Right. So I know customers that are having private cloud and also trade with appliance for sandboxing. So everything is local. Okay, but just to be honest with you guys, the private cloud, even though you have this capability of keeping your events locally, it's a little bit, not a little bit, it's way behind now. Behind, in case of features, it's way behind of a public cloud. Okay, so that's why I would say 99% of customers are using public cloud anyway. Okay, they're not going to the private cloud. Private cloud is more for people that are really keen on security, maybe some public organizations, you know, banks maybe, right? Things like that. So do not think, please do not think that the private cloud is something really popular. It's not. The public cloud is popular, not private. I just wanted to show you the different options here. Okay, guys, so let's take a quick break maybe now, and we're gonna be switching the topic. So the next topic will be the IPS. Okay, so let's take. Oh, where's my minion? Okay, it's gone. Let's take 15. Grab a coffee and be ready for the next topic, which is the most important one, I think, in the whole. Okay. Okay, so see you guys in 15. Okay, guys, let's continue. Okay, so the next topic for today is IPS. Finally, someone say. So again, when the packet is coming to the device, it's going through the preprocessors first, then the security intelligence, then the SSL decryption if it's there, then the security intelligence again, because that's the URL and DNS based, then access control policy, and the access control policy rule can point or send this packet to the further inspection to the IP by the IPS, but by the some policy, IPS policy. So we now focusing on what's going on here. And we have a couple of policies already in the system. We call them system provided. Okay, there are 4 of them. One is called security over connectivity. Another is called balanced security and connectivity. Another is called connectivity over security. And finally, we have maximum detection policy. Okay, what's the difference between all of them? A policy, right, an IPS policy, is just a set of signatures enabled. Right, so we have some total number of signatures in the system, but only some of them can be enabled in those policies. Maybe before I go, let me go back to the lab real quick and show you where we can update signatures. Under the system updates, we have that option to update the product, like apply a patch to the FTD or to the Firepower Management Center. We can also notice the last week we were talking about this, Cisco vulnerability and fingerprint database update. That's the VDB to update the application detectors and to provide information about new vulnerabilities that we can map to host profile. Okay, so those are the product updates, but we have a next tab called rule updates. And here we can schedule updates for snort rules. We call them rules, but I actually call them rules or signatures. I try to call them signatures because it's more obvious what I'm talking about. But actually in the system, they call them rules, snort rules, okay? But if you see, obviously the rules is more, for most people, is more about firewall rules rather than IPS rules, right? So I try to call them signatures, but in the system they call them rules. So notice that the running snort rule update version is, it's old one from the September. No, it's August last year. And we can update it here. So I can basically select or browse for the update, or I can just select download the new rule update from the support site and click import. So if my FMC has internet access, it should go out and reach out to the support site and download new rules. So I will leave it like this. Let it go and update our rules. So we'll see how it works. Okay. Again, we call them snort rules. Okay, so different policies have different rules enabled or signatures, right? So basically, the difference between them is a number of signatures enabled versus a total number of signatures in the system. So for example, in security over connectivity. Okay, let's say we have, I know, today we may have 38,000 of signatures total. So each of policy has all those 38,000 signatures available, but only some of them are enabled. Okay, so for example, connectivity over security may have, because as name implies, we are looking for a security, the connectivity is on the second place. So maybe 15,000. I'm just guessing, okay? We will check that later in the lab. But now I'm guessing. It's highly unlikely that you're going to see all signatures enabled in the system, simply because that's usually not possible, because some of those signatures are old, obsolete. You know, we don't need them anymore. Okay, so and how this industry works is that once you created a signature, and a signature has a number, signature ID, we call it, then this signature will be in the system forever, okay? Even though we don't need it. If we don't need it, it's likely to be disabled, right? So that's why it's highly unlikely to see all signatures being enabled. Okay, so maybe out of those 38,000 signatures total, 8,000 might be the old signatures that never will be enabled. Okay. Balance security and connectivity, I'm just guessing, might be 5,000 signatures enabled. Okay. By the way, this is the one that Cisco recommends you to use if you don't know which one to use, okay? Because that's as name implies, it's balanced. Connectivity over security, that's obviously important for you, is the connectivity, not the security, not that much. So maybe 1,000 signatures enabled here. And the maximum detection looks like it's very powerful and, you know, does everything for you. So maybe, I'm just guessing, 30,000 all signatures enabled, almost all. I don't know, just guessing. We'll check that. Okay. Okay, cool. The problem is, notice when I go to policies, intrusion, notice that my list of policies is empty. It says there are no policies defined. Right? Wait a minute. I said just a minute ago that there are 4 policies already in the system, right? So why I cannot see them here? But if you go to the access control policy and you would like to apply this policy, maybe to a default action or to a rule, let me show that real quick. Notice I have one of them assigned as a default action. I have 1, 2, 3, 4. Security over connectivity, balanced connectivity over security, and maximum detection. So they are here in the system, but I don't see them on the policy list. Why is that? And this is because they are read-only. Okay? That means you cannot edit them and change anything inside that policy. You cannot go and disable some signature if you don't want it anymore, right? Because those policies are read-only. That's why you must use your user-created policies, your custom policies. So user-created policies, custom policies, can be read-write. And when we create one, there are gonna be two layers created: a user layer and something called a built-in layer. When we click create new policy, let me go there. If I click create policy, okay, I need to give it a name, some description, and I need to choose a base policy. I need to choose one of the system provided policies, okay, to be used as my base policy. By the way, you can see that there are 5 system provided policies, not only 4. There's another one called no rules active, which means this is an empty policy. Like you have all 38,000 signatures available, but 0 of them enabled. Okay. What does it mean that the base policy? The base policy is going to go here in a built-in layer. That's going to be base. Oh, let me do this. Okay. Let's say balanced. I choose balanced security and connectivity during the creating the user created my custom policy. So once I use this base policy, okay, I'm going to inherit by default everything that is already set in the balance security and connectivity. So out of 38,000 possible signatures, I'm going to have 5,000 enabled signatures. Okay, and in my user layer, there's a user layer called my changes. I'm going to inherit everything from down to up. So inherit from bottom layer. Okay, but whatever I change on upper layer, that's going to affect or overwrite the bottom layer. Okay, because the thing is that the built-in layer based balance security and connectivity, this is still read-only, RO. Okay, my user layers are read-write. Okay, so I'm using base layer to get some configuration, to get some signatures already enabled that I can use as a base, right, to start with, and I'm inheriting all those settings. So on my changes, I see all those defaults, let's call them. Okay, but I can now, being on my changes layer, I can overwrite something. So I can, for example, disable a signature or enable 10 additional signatures. Okay, why is it so complicated, or why is it created this way? This is because it's easier this way to deal with updates. So if it comes to this is called SRU, snort rule update. Right? SRU is being applied automatically to the system provided policies only. Okay, but since you are using the one of those system provided policies as a base layer, this SRU will automatically affect your base layer too. No. Okay. Okay. Maybe that's a bad wording. Overrides bottom layers config. Oh, it's this way. Let's say that this way, because as an outcome of that, they're gonna be this plus this. This is a policy. We call it policy summary. And this is what's going to be applied as our policy to a rule or a default action. Okay? So this plus whatever upper layer you have, that's going to be applied. So it's not overwriting this, it's overwriting this on this layer, but built in plus my changes equals policy summary, and that policy summary will be applied to a sensor. I will show you that in action, so you'll see how it looks like. Okay? Let me finish that update thing. Each update, when it comes, it has two sections. It can give us some new signatures. Okay? Let's say 3 new signatures, and it has a section for changed signatures. Let's say in this particular SRU, there were 3 new signatures and 5 changed signatures. So signatures that we already have, but some changed have been made to those signatures. Not really, Ramintor. Let me finish that, and I will show you that on the system, so it's going to be easier to understand. Okay. That's not easy topic, so no worries. Right. So we have 3 new and 5 changed. If that's SRU coming to the system, then it's going to affect the total number of signatures, because we have 3 new signatures, right? So there are going to be 38,003 signatures in the system, including in our base policy, because we are inheriting everything from the balance, security, and connectivity, plus 5 changed. Okay? By the way, 3 new. So depending on the policy, on the system provided policy, okay, those 3 new signatures can be enabled in security over connectivity. Maybe 2 of them can be enabled in balance, security, and connectivity. Maybe 1 of them or none can be enabled in the security over connectivity. Okay? And 3 of them can be enabled in maximum detection. Right? So if we are inheriting settings from balance, security, and connectivity, that's going to affect some new signatures, enabled signatures to us. Okay, so remember, the SRU is affecting system provided policies, and since we are inheriting settings from one of them, we also inheriting everything that comes with this rule update. Okay. Again, why I'm saying 3 to 3 here? Because again, out of those 3 signatures, all 3 signatures can be by default enabled in a security over connectivity system provided policy. But for example, in balance, security, and connectivity, only 2 of them can be by default enabled, and 1 is by default disabled in that policy. Okay, but since we are in our user-created policy inheriting all those settings from balanced security and connectivity policy, then we also inherit those two enabled signatures, new signatures from it. Okay, let me show you that in action. So I'm creating a new policy. I'll give it a name like my IPS policy 1, okay? And I'm using base policy, balance security, and connectivity, but I can change that if I want to. I will change in a second. So you see how many signatures are enabled by default. There's a nice checkbox here, drop when inline. That's a very important thing, especially for the first deployment of that system. If you have this checkbox enabled, if a signature has an option to drop a packet, it will be dropping the packet. Okay? But if you uncheck this, even if a signature has a drop packet action, it will not drop the packet, but it will log. So you can consider this checkbox like enabling kind of monitor mode for IPS. If you have it unchecked, that's the monitor mode. You're seeing everything. You see events, intrusion events, but signatures are not dropping packets. Okay, like IDS, but the IDS, the essence of the IDS is to work on a copy of a packet. Here, you are not working on a copy of the packet. You're still working on this is the inline deployment. You're still working like IPS, but you're not dropping. Okay, but kind of IDS monitor mode, or yeah, dry run. Yeah, exactly. That's really nice because if you are deploying this feature, the IPS, for the first time in your network, you never know what will happen in a second when you deploy that. Right? You enable, apply IPS policy to your rules, and deploy those changes to the device, and the device will start dropping packets. And it might be 5 packets a minute, but can be 5,000 packets a minute. So you usually don't want to, that to happen. You want to have a control over it. What's going on when you enable the IPS? So this option, when you uncheck it, that gives you a time. You see everything in the logs, like the IPS works normally. The only difference is that it will not be dropping packets. Okay. Thanks for explanation. Let me show you something. So in order to show you that, I need to open up some more live system, so we can see different IPS events. Give me a second. I'm opening it in a D cloud. Okay, that's a demo for FMC. If I go to the analysis, intrusion events, in that system we have some intrusion events already, so that's going to be easier to show that. Okay. Let me view all individual events. So notice one thing, each event, those are the IPS events, okay? We see in the message column, we see what is the name of signature that was triggered, okay? And the inline result column, this down arrow, black down arrow, showing us that the packet was dropped. See, dropped. If you have, this is a regular, normal behavior, but if you uncheck this checkbox, okay, if you uncheck it, then you're still gonna have all those events. The only difference will be in this inline result column, because this down arrow will be grayed out, will be gray. And if you hover your mouse on it, there's gonna be a message saying would have dropped, which means this packet would have dropped if we have this checkbox enabled. Okay, so that's this is how we can see it, and that's the power of it, because you still see all events. The system works like it would normally work, except it's not dropping your packets, and you have time to do something with it. You have time to figure it out, what's going on. You can tune your policy. You can maybe disable something or change something in the policy to not have those events. Okay, because remember, most of those events are gonna be false positives, right? False positive is when there was no real attack, but you have an event. Okay, and the whole idea is to let it or minimize the amount of false positives. Okay, let me create that policy. I can still have this drop and inline. This is the lab. So I click create and edit policy. So what's gonna happen now? We're gonna be created a policy with two layers, with a my changes layer at the top and a base layer at the bottom. The base layer will be still read only, and my layer will be writable, so I can change something. Let's see how it looks like. Okay, I hope that my update is already done, the rule update I scheduled. Okay. So notice that the rule update now I have from the 1st of April. So that's the latest one. My base policy is balance, security, and connectivity. I have this drop one inline. Okay. And I see that this policy has 11,453 enabled rules / signatures, which most of them, notice, 95 only generate events, but most of them are dropping packets and generating events. Okay, this is how it should be. So if I go to the policy layers first, see, I have two layers, my changes and balance, security, and connectivity. If I click on the policy layers, you're going to see that this is a built-in layer, the balance, security, and connectivity. My layer is under the user layers, and at the top of that, we have a policy summary. So basically, policy summary means this plus this plus this plus this equals what's going to be applied to the device. Okay, so if I go to the policy, the base policy, to this layer for rules, or to see the rules signatures, okay, I see the signature like here, but all options are grayed out. I cannot change anything here. It's all read only because that's the base policy. But if I go to the layer my changes, I can switch to it by selecting that from the drop down or by clicking my changes rules here on the left. Notice now I have all the options available. Okay, so this is a read. The base layer is read only. This one is writable. So, for example, if I now select 3 signatures and change them to drop and generate events on my changes layer, see, I changed the rule state for 3 rules. Now it says that they are in a bold font, and there is a red cross saying this is going to drop and generate events. If I go back to the policy layers, notice that my base layer has 11,453 signatures enabled. Now on my changes, I enabled 3 signatures, additional signatures. That equals this plus this, 56, not 53. See, 53 plus 3 equals 56. So this is the number of signatures that's going to be sent to the device. Okay? So I'm not like overwriting this. I'm overwriting the state, but on my layer. Okay. And what's going to be applied is actually the, everything together. This plus this. Okay, this editor here, the rule editor, is allows you to see all the signatures. Okay, so you can use it to enable some signatures, disable some signatures, to change some settings here. But to be honest, nobody does it this way. Nobody does it this way. Right? No, I'm not using shirt layers. I know that maybe someone can find it useful, but I don't think so. So the question in the chat is about shirt layers, because you can add new layers. You can add new layer, or you can add new shirt layer. A shirt layer is a layer that you can get from other policy. Okay, so you can borrow a layer from a different policy. You can share it across different policies. And then only one change in the one policy affects all other policies as well. Okay, so that's really efficient and flexible, but I don't see many people use it. Okay, back to for a second to this rule editor. Okay, so on the left you have different categories. You can find your signatures. Okay, if you wish. By the way, I don't have any signature selected now. So notice 0 selected rules from 41,093. So this is the number of signatures in the system, the total. Right, so I set 38,000, so it's not 38 anymore. It's actually 41,093. Okay, so that's not correct number. How many signatures enabled in the balance, security, and connectivity? I can go to the policy layers and tell you that. 11,453. So actually here, balanced, right, was 11,004. What was it? No, 53. Balanced. What about other? Let's check that. If I go to the policy information, I can change the base policy if I want to. I can change to, let's start with security over connectivity, maybe. All right, so I said 15,000. We'll see. It takes a while, but this is a nice exercise to see how many enabled signatures we have in individual base policies. Oh, 17,757. It's not 15, it's 17,757. Right? Balanced and connectivity over security. That's going to be shocking, I believe. It's worth the wait for it. Right, so the connectivity over security is about when you're more interested in having the connectivity rather than security in your network. So security, yes, but a minimal one. By the way, guys, is everything fine with my my audio now and video too? What I'm sharing? Yeah. Okay. Thanks. Okay, great. Thank you. Right. So notice this: the policy connectivity over security has only 523 enabled signatures. 523. See, this is really, really low, right? Comparing to 41,000 signatures in the system, only 500,000 is enabled. That's nothing, right? So if you choose connectivity over security for any reason, it's like you have no IPS, in my opinion. You have something, but it's really, really base, right? It's not really protecting you against anything. Okay, and the maximum detection. Let's see that one. Okay, see, 32,000, 32,226. Oh, so I was close. 32,226. So it's really, really a lot of more than the security or connectivity. It's twice that much, almost, right? So it's pretty powerful. But by the way, the maximum detection is not something that I would recommend for you, because the maximum detection has some signatures, may have some signatures enabled that might be overwhelming for a system. That's the one thing. Another thing is that maximum detection is the system provided policy that that TAC, Cisco TAC, Technical Assistance Center, is using to test some signatures for customers. So if a customer has a some issues with the IPS, and they work with TAC to resolve that, maybe TAC can adjust some signatures for that customer, and they are using maximum detection for it. By the way, the previous name for a maximum detection policy was experimental policy, and I think that was a better name than the maximum detection, because maximum detection is something that looks nice, and you want to be secure. So at the end of the day, it's better to be secure at the maximum level, right? So yeah, I think it's not the fortunate wording for it, but anyways. Anyway, if you want to really use IPS, I would not recommend to use any of these system provided policies. Okay, you must create your user custom policy. Okay, and here's why. Because if you want to tune up your policy, how you can do that with a system provided policies? Actually, you cannot, because they are read-only. So let's say I have a policy, my firewall policy, some rules, and I applied balance security and connectivity IPS policy to those rules. If I have a false positives, meaning there is no attack, but there are a lot of packets being dropped to that server, that specific host, I cannot go to the balance security and connectivity and disable that signature, or change any settings in that signature to not generate events, to not drop packets. I can't do this, because the system provided policies are read only. I must use my own policy to do that. Okay, and by the way, in those system provided policies, you have a number of signatures that shouldn't be even enabled in your environment. Okay? So it would be really nice to have an option to tune, right, our policy, and we cannot tune something that is read only. Again, that's why, in order to use actually the firepower recommendations that I was talking briefly about last week, we need to have a custom policy. So firepower recommendations, that's the biggest thing in the IPS, I believe. Remember, based on the network discovery, right? We have a network discovery policy. We already tuned that. Remember, network discovery policy should build a host profiles for network or for hosts that we protect. Right? So let's say we adjust it to include 10/8 network, and we, as an action, we set discover applications and hosts. Right? Applications is there to do the application detections. Host is to build the host profiles. Once we have a host profile created for our host, right? We know the IP address of that host. We know the operating system like Windows 10. We know what are the applications running on that host, like client applications, Firefox 72, IE 60, like SSH client, or whatever it is, right? We see the client applications. We have protocol. We see protocols, services, if that's the a server. We see that on a TCP port 80 there is an Apache 2.2 running. We see that on a TCP 21 there is an FTP server running, and so on, right? So based on what was discovered passively, we built that vulnerability or map, actually, the vulnerabilities here. Right? We know that, okay, that's IE60 is vulnerable to this, 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 and that. Windows 10 is vulnerable to this and this. Firefox is vulnerable to that and that. So we apply or map vulnerabilities to the host profile based on what was discovered on that host. Now, in case of IPS, we have those host profiles. Right? We take all those vulnerabilities from the host profiles, we put them all to the kind of database, to the one big bucket, right, of all potential vulnerabilities that we have in our network. Right? And the system can take one by one out of this database and check if we have a signature for it. If we have a signature or snort role, we recommend to enable it. Right? So we go to the signatures, we check, we have vulnerability 1, right? We check is there a signature for it, okay? If yes, then we recommend to enable it. If no, obviously we cannot disable, okay? So if no, leave a default, right? So basically we're checking all the vulnerabilities that we have in our network. One by one, we check if we have signatures for them and recommend to enable those signatures. Everything else can be disabled. This is how firepower recommendation works. So, and the only option to, or the only way to use this feature is to have a custom policy, because under the custom policy, we have noted here, firepower recommendations. And what I can do here, I can just click generate and use recommendations, or just generate recommendations and not use it, not use them. Let me click to do the simplest thing possible. Just go to the Firepower recommendations and click generate and use recommendations. This is what the system does now. It's checking my host profiles, taking vulnerabilities from those host profiles, checking signatures for those vulnerabilities, and enabling or recommending the signatures to be enabled or disabled. So let's see what's gonna happen with the Firepower recommendations. That's the best way to initially tune your IPS policy. Very good question in the chat. Are these recommendations updated automatically? And the answer is no, not by default, but you can schedule that to automatically update recommendations. I will show you that how to do this. So this feature, the Firepower recommendations feature, is the feature that made SourceFire, the #1 IPS in the world, because that, legend, because that was the most critical thing and the most overwhelming thing for a system administrator, for IPS system administrator, how to deal with false positives and that number of false positives that we have, and the false positives are mostly generated by wrong signatures. I mean, signatures that are not meant to be enabled, or they shouldn't be enabled in our environment. Okay? The more signatures we have enabled, the more false positives we're going to have. So it's not the case that, many people say, you're saying, but it's because if you enable all signatures, that's going to kill the system. Yeah, that's the one thing, most likely. But the most important thing is, if you enable all signatures, you're going to have a lot of false positives, and you will spend a lot of time figuring out what's going on and why this signature is being triggered. Okay, and normally you don't have any knowledge. Otherwise, you should know everything about all possible systems, vulnerabilities, signatures, everything, in order to make a decision which signature should be enabled, which should be disabled in your system. And this Firepower recommendations feature will do that for you, based on vulnerabilities that we have currently in the system. Obviously, those are potential vulnerabilities, again, quotes, double quotes, because they came from a passive scan, right? We see what's going through the system and we learn about it. So we know that there is a Windows 10 or Windows 7, but we don't know what is the patch level of that system. Maybe the system is fully patched, and there are no known vulnerabilities on that system. right? So there shouldn't be any vulnerabilities mapped, but we have some vulnerabilities mapped to that host profile based on the operating system because we know only that this is Windows 7, and Windows 7 is potentially vulnerable to those 200 vulnerabilities. So, yeah, if you want to have, a really valid information, you should consider integration with a third-party vulnerability scanners. No, recommendations are not, not having that. They are just doing this based on the CVE that they see in the host profile, in the vulnerability. You can catch scan actions. You can catch that with a preprocessors. For example, there is a preprocessor that allows you to alert based on this, to find out that there is a scan. Okay, notice that it's setting the policy to use recommendations. That's going to add, notice the policy layers here on the left. Now, for now, I have my changes and maximum detection as a base layer. But there's going to be another layer created here in a second called firepower recommendations. It's going to be above the base layer. Will override the base layer settings. That takes a lot of time here in my system. Oh, here we go. Notice that there is a new layer, firepower recommendations. It's above the base and below my changes. Right? If I click OK, notice this. The firepower changed 40,000 plus rules for 8 hosts because I have only 8 host profiles in my system. That's a lab system. Okay, it's firepower changed those 40,000 signatures, setting 0 to generate events, setting 427 to drop and generate events, and setting 40,040 rules to be disabled. So if I go to the policy layer now, notice that maximum detection, the base layer, had 32,000 enabled rules. Right? Firepower recommendations added or enabled 427 rules. Okay? Plus 3 rules that I have here, and that obviously not equals this plus this because some of those rules may already be enabled. So, anyways, the summary is 1,000 rules that should be sent to the device. It should be applied to the sensor. So notice from 32,000 enabled signatures, we limit them to 1000 only. And it is enough to have 1000 signatures applied to my device in order to protect my network at the moment, right? Because now that was based on my host profiles at this very moment. So back to the built-in base layer. Notice that if in case when you are using firepower recommendations, it doesn't really matter if you use maximum detection as a base layer or connectivity over security as a base layer or even no rules active as a base layer. Because anyways, everything will be overwritten by the firepower recommendations. Okay? So base layer doesn't, make any change here if you want to use firepower recommendations, because everything will be overwritten anyway. Okay? That was the easiest way to do. Now, when I click on the firepower, get back to the firepower recommendations, I will show you. Obviously, you can see what changes have been made. You can click View here on the right to see what rules will to be disabled, what should be enabled, and so on. That's not that important. Nobody does it, this way, like going to those individual signatures and they are enabling or disabling those signatures. No. Notice, by the way, those 3 signatures that I enabled on my changes layer. See, those 2, the first one and the third one, has the recommendations to be disabled in the firepower recommendations. Right. So yeah, this is how it works. So nobody does it through this editor. This is what I wanted to say. Okay. You don't really need to know what those signatures are doing. Okay. You just going to the firepower recommendations and the system should give you the recommendations. Okay. So, but it's based on the host profiles, and the host profiles must be, vital, must be real, must be good as possible. Okay. So it's up to you to configure the policy, discovery policy in the correct way, to maybe inject some information from the external third-party vulnerability scanners, things like that. Okay, that was the easiest way to do. I just clicked generate and use recommendations. Okay, but we have some advanced settings here under this plus, icon. There are 3 settings that we need to talk about. First one is the networks. You can limit the scope of the host profiles that the system will look at. Okay? By default, this list is empty, which means all host profiles that you have in the system will be taken into consideration. But you can still say, yeah, I want to only the system to go through the host profiles in 10/8. I don't want the system to go to 192 or to 172. Okay, or even different subnets if you want. So you're limiting the scope. Why you would need that? Let me show you an example. If you have a FTD, let's say deployed like this, you have 2 things. This is the inside, network. This is the DMZ. right? So you have two use cases, let's call it this way. One use case is your users to the internet access, okay? And here you are protecting your hosts, those hosts. Those hosts are usually Windows, Windows 7, Windows 10, right? Those kind of hosts without, services like Apache, IIS, and so on. Okay? Another use case of the same device is this: users to the DMZ. Yeah? And here you can see what those hosts can be: some web hosts with Apache, with Linux rather than Windows, and so on. Right? So completely different operating systems, completely different host profiles. Let's say this network is 10/8, user networks are 10/8. This network is 172.16/12. Right? So, or maybe for easier understanding, 1/24. Okay. Now, in this case, I would create two different IPS policies and two different recommendations, because to protect my inside hosts, they have probably completely different vulnerabilities than my DMZ servers. Right? So it would be beneficial to create two different firepower recommendations for them. Checking the chat. But that depends when you have the FTD, right? If you have the FTD on a data center, and you're talking about the data center east to west, that's generally it's a bad idea to enable the IPS there. I would say, because east-west connectivity in a data center is completely different than north-south. Right? North-south is the user to data center. That's the well-known protocols like HTTP, SQLNet, stuff like that. But in case of the east-west type of traffic in a data center, there are tons of different, strange-looking, not compliant with anything protocols. So having a system like this on the east-west, that's going to be a nightmare to manage. Going to be a lot of false positives, packets dropped, and so on. So I would not recommend even doing this. Right? But here I'm talking about two use cases. The users, I'm talking about two different operating systems that we are protecting. Here is completely different, Windows-based user applications, and here Linux-based servers, web applications, stuff like that. So completely different environment. Right? So in this case, it would be beneficial to create different firepower recommendations. So I need to have two different IPS policies to have different firepower recommendations, right? Because let's say this IPS policy 1 I'm creating is just for 10/8, so for my users, for Windowses. And I create another policy, policy 2, when I configure firepower recommendations for 172.16.10/24. Just give me recommendations for my host in a DMZ. Okay, so that's the one thing to consider. Another thing is the rule recommendation threshold based on a rule overhead. Let me go back to the My Changes to see some rules. If I double click that, that's gonna show me some additional settings here, including how this signature or rule is created in the SNORT language, some documentation, references, which was the SNORT rule update that this rule was added to the system, and so on. And notice that each rule has a rule overhead. Okay, the rule overhead can be low, medium, high, and very high. This is a setting, or rather properties, not the setting, property of a rule added by a rule author. So when a guy at Cisco is creating a rule, he knows that, okay, this rule will have a high or very high overhead because I used in a rule some maybe complicated, I don't know, regular expressions, okay, to find out the content in the packet that I'm looking for. And I consider this rule to be overwhelming. Okay? So adding this rule overhead or setting this rule overhead to very high. The next one, let's check, also very high. Next one, very high. Notice that this one, or the fourth one, is high. It's also high. Right? So rule overhead. And the firepower recommendations by default is looking only to give us the recommendations. It's looking only for rules that have an overhead from none to medium inclusive. Right? They are not taking into consideration high or very high overhead rules, which means, right, they will never be able to enable or recommend that to enable a rule like this. They will never recommend to enable this rule. Maybe that rule is important in my environment and I would like to have it enabled. What to do if I would like to have it? We need to change this to high. High means high and very high. Okay, but you need to be careful with it because that might be too overwhelming for your system. Remember, the high and very high overhead rules are utilizing regular expressions, stuff like that, and they can be really overwhelmed for a system. So the best way to approach that is, in my opinion, is to make a test. To create one policy with firepower recommendations set to the medium, apply that, see what's going on, how the system behaves. Next, create another one with a high, including high and very high, and then apply it to the sensor just for testing and see how this will affect my system performance. If it's too big impact, then I need to get back and apply the previously created policy, right, with a medium setting in it. And finally, the option to accept recommendations to disable rules. That's the default. So if we don't need that rule, then we can disable it. Okay? We can uncheck this box if you don't want to disable any rules. Then the recommendations will just give you or add some rules on top of the rules that you already have. Okay. So this is how the firepower recommendations work. And that's not all, because the next thing I wanted to talk about, but that's going to be actually after the quick break, is the option. We need to talk a little bit more about something called a variable set. The variable set is one of those things that are so important that must be adjusted in order to make this system work optionally, more optionally for you. Okay. If I would pick two things that must be correctly configured on the firepower system to make that work correctly, is number one is the network discovery policy. Number two is the variable set for IPS. But I will talk about those after a quick break. So let me schedule a break. Okay, so you guys grab a coffee and we'll be back in 15. Thank you. Okay, guys, let's continue. Right. So the next thing I wanted to talk about in regards to the IPS is the variable sets. Okay, maybe before I go into the variable sets, let me show you how a typical rule looks like. So I'm going to copy a snort rule, the notepad. Okay, so a rule consists from two parts. One is a header. Another one is a body, rule body. So basically, a header is describing what traffic should be subjected to that rule, and then the body is describing what's inside the packet that we are looking for. Example, the most common keyword here is a content. Right? So for example, here we are looking for a ASCII string Ruby, then 3A in the hex. Then this is the PCRE, this is the Perl compatible regular expression. Right? So regular expression is being used as well. Okay? So that's the content that we are looking in the payload of a packet. But before the content is being looked for, is the thing is that the rule must be classified by this header. And inside the header, we see some variables. Right? So if you guys familiar with how to program, how to create computer programs, the $sign and the name usually reference to some variable, and exactly the same here is here. Right, so we have in this particular rule, we use external net, HTTP ports, home net variables. Where those variables are created. Let me get out of it, so I need to commit the changes. Optionally provide a description here just to save my policy. Once the policy is saved, I can go to the variable sets. So let it be for a second or two, and we will be doing the variables in a second. Okay, so my interim policy has been saved, and notice that the status says that no access control policies use this policy. That's obviously true because I haven't assigned this policy to any rule yet. So, but before I go and do that, let me go to the objects. And inside the objects, we have a variable set. So on the list on the left, we need to find variable set. And there is a default set in the system. Let me show you how the default looks like. The default set, variable set, is a container for variables, right? So we have a different variables with their default settings. For example, external net variable, the value for it is any. If I take a look at our header, our header would look like this: alert TCP any, because external net equals any by default. What about HTTP ports? This is the list of such HTTP ports. Okay, it's quite overwhelming. So let's call it HTTP ports. Then direction towards, home net. What is home net? Home net equals any as well by default, and any as a port. Right, so basically this rule works for anybody that is replying back to us from HTTP well-known port to any IP address, right? So the first question is, is it really like this that we need to know all HTTP ports that the server can listen on? Because that can be anything actually, right? If somebody opens an Apache on port 1234, that's going to be 1234, and so we need to know that and go here and add this port to the HTTP ports variable list. Fortunately, not. So because those ports are being ignored when in a body of a rule we have a service keyword, and we have a service HTTP. That means that the snort will be using application detector to detect if that's HTTP or not. So basically, instead of HTTP ports, I should say any HTTP based on a HTTP detector, protocol detector. But still, this rule is pretty open, right? It's now saying from anybody on any HTTP port back to anybody. Then check the content of that packet. If you see something like this described in the content or a regular expression, in this case, right? What I'm trying to show you is a kind of problem here. Let's say we have our FTD again on the internet edge, right? Protecting our users going out to the internet, but also protecting our DMZ. You know what? I need to redraw it. That I must have more space here. Users going out, and let's say some DMZ. Let's say we have a DMZ1 with some hosts. We also have a DMZ2 with some hosts. Okay, so in this case, we are supporting 2 or even 3 different scenarios. Right? We are supporting our users going out to the internet, so 10/8 going out to the internet. Case number 2 is somebody from the internet going to the DMZ1, and in a DMZ1 we may have some Linuxes, right? Linux servers running on some ports, 1234, port 80, and so on. It's a 172.16.10/24 network. And we also have a DMZ2 and another use case, users from the internet coming to the DMZ2, and we have some Windows servers here. And this is 172.16.2.0/24. So in this case, I would recommend to create 3 access control policy rules. Rule number 1, right, would be the users to the internet on port 80, right? The action should be allow, right? And I should have IPS a policy for users created. Right? Another rule I would create for those Linuxes. What's going on here? Rule 2, internet to DMZ1. Right? That's the internet to DMZ1. DMZ1. Again, on port 80, allow, and that should have another IPS policy, specially crafted for DMZ1. Why? Simply because if we take a look at those policies, let's say this is the user's policy, IPS policy, right? We have firepower recommendations for users. Right, for 10/8 only. Because here we have some Windows's, basically user workstations. But here in rule number 2, we should use another IPS policy for the DMZ1 and some signatures enabled based on the firepower recommendations for 172.16.10/24. Right? Those recommendations will include Linux's signatures for vulnerabilities on the Linux boxes. And likewise, rule number 3, it should be init to DMZ2 on port 80, allow, and IPS policy for specially crafted for DMZ2. Right? With firepower recommendations for 172.16.2.0. Now, this is about IPS policies, but inside those policies we have signatures, and those signatures are configured this way. Let's say this signature is enabled in all those 3 IPS policies. Right? If that's the case, let me maybe move it here to the right. Right, so you see this on the one screen. Notice, if we have alert is basically ignored by the snort on the firepower. This keyword alert doesn't really matter, okay? The TCP is a TCP protocol, so that's gonna work for anybody that is responding with HTTP. So that's gonna work for a returning traffic from the internet back to the user, right? That's gonna work for the returning traffic from our Linux server in a DMZ1 back to the user on the internet, and the same for DMZ2 if those Windows is listening on HTTP, right? That's gonna work for returning HTTP traffic to anybody. Now the question is, where are the hosts that we are protecting? They are not on the internet. We are protecting this DMZ, we are protecting DMZ1, we are protecting our users, right? So you see the point here? We shouldn't have this signature working in a wrong direction. Right? It's okay for users, for a traffic from the internet back to our users. That's okay. But it shouldn't work, this signature shouldn't work for Linux back to the internet user, because we are not protecting this internet user. We are protecting our Linuxes. So this signature shouldn't work for them. Notice, by the way, this signature is more for a client, not the server, right? It's for a browser Chrome. So it's a signature that should work to protect the client, right? But in our case, if we have variable sets configured to any, then this signature will work in a different directions as well. Not only protecting clients, or maybe, okay, protecting clients, but not our clients. Right? Do we really care about that? Not really. I don't want to have false positives because of that. That's my goal. That's why one of the most important things to be done in that system is to change the variable set, to adjust the variable set. You can adjust the variable set default, but if you do that, that's going to affect everything in the system. It's better to create your own variable set that will inherit all the settings from a default set and then change it. For example, I'm going to create a variable set 1, you call it users. Okay? And in this case, I'm going to change my home net from default any to the network that I protect. I'm protecting my users. My users are in a 10/8 network. Okay. I can also do something like this. What about external net? It's still any, right? So including the private IP addresses. In this case, that shouldn't be the private IP address. The external net for my users is the internet. So I can do something like that. Instead of any, I can create a variable like this. External net is home net exclude, which is basically external net is not home net. It's everything else but home net. Okay. See what I done? So basically, what you need to do to correctly configure it, you must create variable sets and adjust the home net to be your network that you protect. That's the golden rule, I would say. So to add to that variable set, okay, I would create 3 variable sets in that particular example. VS users, where the home net equals 10/8. I would create variable set DMZ1, where the home net equals 172.16.10/24, and I will create another VS for DMZ2, where the home net equals 172.16.2.0. Okay, and then apply those variable sets to my IPS policies. So notice when I go to the access control policy roles, whenever I have intrusion policy to be assigned, for example, I will assign intrusion policy I just created for my first rule, and click this shield. It's going to take me to the inspection tab, and intrusion policy is set to none. I will choose my policy that I created. But notice whenever I use intrusion policy, next to it, there is a field to provide variable set that this policy gonna be using. So in my case, I'm gonna use my new variable set VS1 users that I created. Okay. Then I'm protecting the correct networks. Okay. In a default action, notice the default action when I use intrusion prevention as a default action, there is also variable set that you need to assign here. This $sign next to it, if you click, you have variable set to choose that's going to be using by this intrusion policy. Okay. You may ask a question, what about this external net? How to deal with that? Because that's usually the problem. Okay, so in case of the users going to the internet, that might be okay to set external net to not home net. But you need to be careful with that setting, because if you do that, something that is, you know, maybe in a DMZ or in external net, sorry, in the extranet, is not gonna be treated as a home net. What do I mean? Let's say you may not catch internal attacks. Let's say you have FTD, external net, right? You protect, you go into some partner networks, right? And this network is this and 330, and you have network 10.1.1.0. So if you say home net, right, is 10/8, that's not true, because those two are external to you, right? But you can say home net, right, like this. If you do home net, sorry, external net, is not home net, right? That's still allowing those guys to attack you, right? Because 10/8 and everything else is not home net. So you need to be careful, right? If let's say another example, you have 10.5.5.0 network, and that's your internal network. And if somebody from here attacking you, right, you will not gonna catch it because of this external net is not home net. You need to be careful with that. Sometimes it's better to just leave external net set to any, and just adjust the home net only. So you need to be careful with those settings, because some signatures may not work at all for some flows or some traffic. Okay. Right. So I applied my intrusion policy with a variable set to a rule. I can now save my policy and deploy. So I think now it should be clear for you how to create or how many intrusion policies to create. Right? It's not the case that you're creating one intrusion policy and apply to all rules. It's rather a per case basis, per use case, I would say. Right? This internet to users to the internet or internet to the DMZ, stuff like that. You need to consider this based on the traffic that you like to monitor and hosts that you'd like to protect. It's recommended to change value. Okay, set in a default action. Yes, I think it's a good idea to change even to change the default set, to put a home net quite broad, like to network or networks that you protect. Okay, so the default set you could set to 10/8, 172, and 192, all private IP addresses. Not value set, but variable set, right? Variable set. So as I said, you can still use the default set in the default action, but I would anyway go to the variable sets here and adjust the default set, at least changing the home net from any to something like that, all private IP addresses, right? But there's going to be information that this variable set is being used. Okay, that's fine. But if you do that, you need to remember that when you now add the variable set, the home net is already set to the setting that you have in the default set, because you are just like inheriting all the settings from the default set. You can still delete that here and create your own, but you're now inheriting those settings. Yeah, no problem. Okay. And the next topic, also related to the IPS, is preprocessors. Right, so here we have a packet, and the very first thing that is happening is a decoder, which is also a preprocessor, then a set of preprocessors, then the security intelligence, and the rest of the flow, right? So now we are focusing on those things. One of the most important preprocessors that we have here is the IP defragmentation. Because believe me or not, but the most a very common or the most popular way of evading the IPS system is to use the fragmentation, right? So that's why IP defragmentation is a key component here. Okay, for those of you who are not familiar with fragmentation, defragmentation, what is this? If you have a client, right, and you have some maybe routers, then you have some IPS here, and you have a server. When you send a packet, there is always something called an MTU, right? Maximum transmit unit. So if you have MTU of 1500, which is a default for Ethernet on the client, it doesn't really mean that 1500 will be all the way to the server. Maybe MTU can change somewhere. Let's say those two routers have a lower MTU here, like 1400, right? And you have 1500 again here and 1500 here. Why do we need that to the lower MTU? We don't need that, but sometimes if those routers are doing some additional encapsulation for a packet, like maybe GRE tunnel or IPsec tunnel between those two routers, there's going to be some additional data added to the packet, right, to encapsulate the packet. That's why the data inside the packet, it must have a lower MTU. So MTU changes along the way. Now, the thing is that when the client is sending 1500 packet, this router, okay, so this is going to be one packet. When this packet hits this router knows that this is not possible to send that packet as a whole to another router. So this router will divide this packet to two packets. Okay. So now this router is fragmenting. This is the fragmentation, we call it. Right? And the thing is that by the way, guys, who is responsible to defragment packets? Is it the router, the next router, or the destination host? Who is responsible for defragmentation? Right, host. It's always host that is responsible for defragmentation. Fragmentation can happen along the way by somebody, but defragmentation is only done on the destination host. Okay, it's not happening in a network. I mean, the fragmentation is not happening in the network normally. But in our case, IPS must be able to defragment. Okay, send the one packet, actually, no, defragment just to see the whole packet, but it's still sending the two individual packets to the destination, and the destination is defragmenting. Okay, why is that? Because let's say, following example, we have an attacker that is sending packet, and in that packet we have a payload attack. Right? Let's say this attack keyword in the payload is exploiting some vulnerability on a server. Right? In the network we have IPS, and we have a server, destination server, or we call it target of the attack. Right? Now, this packet is being sent out. IPS has a signature. Right? And the signature has a content keyword attack. Right? So it's looking in the packet for a keyword attack. And the action for that is drop the packet and generate event. Right? So in this case, our target server is protected because we're going to drop the packet. That's why attackers are so clever. They are not sending this attack in a one packet. They are trying to trick the IPS device by fragmenting this packet. Let's say sending the same in two packets. One gonna be ATT and ACK in another packet. Two packets. Right? So IPS, even though normally in the network, the target server, the destination server is solely responsible to defragment those two, right? And if that's the case, the server will defragment, and there's going to be the attack, so some vulnerability on the server can be exploited, right? But if we have IPS on the way, IPS should be able to defragment instead of the server, right? If IPS defragments that packet correctly, that packet should be dropped. Okay, so that's pretty easy, right? But the problem is that we have 7 different methods of fragmenting and defragmenting packets. 7 different methods. So different operating systems doing that in a different way. Windows is doing this in one way. Linux is doing this in a different way. Cisco is doing this in a different way. Solaris, HP UX, BSD, Mac OS. Okay, there are 7 different methods of fragmenting and defragmenting packets. So an attacker, if he knows what's on the target server, and he knows that about from what? From the reconnaissance, right? That's why the reconnaissance phase of an attack is so important, because we need to know what we are trying to attack. So if we are attacking Linux, right, we need to send an attack, exploit to some vulnerability. That's the first thing, but we also need to send it in a specifically crafted way, right? We need to send this attack maybe using the fragmentation, because we need to assume that there is an IPS in between. And maybe the IPS will not be able to correctly reassign or defragment this packet. Reassign, it's reassemble, right? Reassemble the packet or defragment the packet, but the target server will do that correctly. Okay, so let's say another way of sending this is like this: at AT, maybe TTA. Notice that there is an overlapping, right? So 3 packets plus overlapping. If the IPS is using Windows method of defragmenting packets, that's gonna be something like this: ATACK, right, with a 1T. Right? That's gonna not trigger the signature, but the server, the destination server, can defragment correctly and be exploited. Okay. So, by the way, most of IPSs today are using defragmentation, but also most of them are using one method to defragment packets, which is the Windows's or Microsoft method. And this is because Microsoft is the most popular operating system. Right? So the good IPS is doing the defragmentation. The best IPS is doing the defragmentation as the target server would do. Okay? That's very, very important thing. Right, so here we have IPS should defrag packet the same way as the target system. Now my question to you guys is, in case of firepower IPS, do we know what is the operating system on the target? How do we know that? Obviously we know this, right? Right, exactly, host profiles. And if we have a good network discovery policy, we should have that already in a host profile. What is the operating system? And now once we know what's there, we can choose the fragmentation method on the fly. So if we see the attack, we know that this attack is targeting this host, and there is a Linux on that host. We should defragment packets the way like Linux would do. Okay? If that's Windows, let's do Windows. If that's Mac OS, let's use Mac OS defragmentation. Okay? And there are 2 ways of doing this. I mean, because notice that in case of FTD, we have our host profiles where we don't have them on the FTD. We have them on the FMC. So FMC is aware what is where. It would be nice that FMC is sent a message to the FTD about what the operating system on what IP address. Right? So we can do that in 2 ways. how to choose fragmentation method. We can do that manually by configuring something called a target in the IP defragmentation preprocessor. PP, okay, let me put the PP, and that's the preprocessors, which is quite overwhelming, and as every manual, any manual method is not really reliable. Or automatically by using something called adaptive profiles, and that's actually enabled by default. Adaptive profiles. Adaptive profile is nothing more than an IP to operating system mapping. Okay, and we have a database of those mapping to be copied from FMC to FTD. Right? So that's basically here, OS IP mapping sent to the FTD, right? Because FMC builds the host profiles, creating all those, and then sending just IP to operating system mapping to the FTD to use to better to decide what will be the defragmentation method on the fly. I will show you this option later, okay? But before I go into that, I need to talk a little bit more about the preprocessor's configuration, and that's going to be quite difficult to understand, guys. So you'll see. Okay, preprocessor config. Actually, we configure preprocessors in something called a network analysis policy. Right? We call it, or short NAP, NAP. Right? So NAP is our configuration. The problem is that we have 4 of them. Okay, that's not the problem. We have 4 of default network analysis policies. The problem is the names of those policies are exactly the same as names for IPS policies, which is security over connectivity, balanced, security and connectivity, connectivity over security, and maximum detection. But instead, even though the names are the same, inside of those policies are no signatures. We don't have signatures. We have preprocessors. So for example, IP defragmentation, this preprocessor is always there. It's always enabled with some settings in it. Right? Because that's very important to have that preprocessor enabled all the time. But maybe in the security and over connectivity, we have some additional preprocessors like HTTP preprocessor, some inline normalization preprocessor. Here in the balance, we can have HTTP preprocessor, but with completely different settings in it. Okay, some FTP preprocessor, and so on. So those are NAP, different network analysis policies are having different preprocessor configuration. Okay, and that's the preprocessor config, this policy, preprocessor config. So settings for individual preprocessors. But the real problem is about logging, because each setting in the preprocessor can drop a packet. Okay? If the packet is not compliant with that setting in the preprocessor, the packet will be dropped. And by default, it's going to be the silent drop, which means we don't have any clue that the packet was dropped. We don't see any event of that. Okay? In case of signatures, right, each signature has a state, has an information. Okay, this signature should drop a packet and generate event. So we automatically have an event. In the case of preprocessors, there can be some setting that will drop or will be dropping the packets, but this setting may not log any events. And the problem is, and this is because the preprocessor logging is in a different place. Preprocessor logging is actually based on the preprocessor signatures. Okay. There are specially created signatures for preprocessors with a GID, generator ID, above 100. By default, all Snort regular signatures have GID of 1. Okay, GID above 100 are the preprocessor related signatures. So preprocessor related signatures, GID above 100. Okay, where do we have those signatures? We have them in the IPS or intrusion policies. So again, we have intrusion policies named the same way as NAP, security over connectivity, balanced, right? Connectivity over security, and maximum detection. But this time, instead of regular signatures, obviously regular signatures are always there as well, but we have specially related signatures to the preprocessors. We may have some of them enabled, like preprocessors signatures, maybe, I don't know, 100 signatures enabled here, 75 here, 10 here, and 120 here, something like that. Okay, just guessing, because I don't know what is the number here exactly. And that's the problem to understand that preprocessor configuration is in a different place and the preprocessor logging is in a different place. And I think to show you that, I will show that on a real world example. I mean, I had I had that situation in the past. Actually, not myself, but I was a teacher. Actually, I was teaching some workshop, a custom workshop for a customer, because they had an issue with preprocessors, and they wanted to know more about that. Let me show you that and describe this first, and then I will show you the settings of the preprocessors that were causing those problems. There is let me tell you about a TCP session hijack. Preprocessor option. Okay, there is a preprocessor called TCP stream. Okay, TCP stream. Under this preprocessor, we have a TCP session, one of many options there. We have a TCP session hijack option that is enabled. Okay, what is this option doing? This option is to monitor a TCP through a handshake. So you have a client, you have a server, right? You have a TCP SYN packet first. When the TCP SYN packet is sent by the client to the server, FTD keeps MAC address of the client. Okay. Then, when we see TCP SYN ACK, okay, FTD keeps MAC address of the server. Okay, or the next hop router if that's a routed environment. Okay, because the client and server might not be directly connected to the FTD, right? And now once this is done, then when the data packets are crossing the data session packets, FTD compares MAC or MACs, client and the server, in data packets to those MAC addresses that it learned from the TRIA handshake. Okay, why is this check for? This is because we want to protect against session hijacking or injecting packets into the current session by somebody else. Okay, so this somebody else will have a different MAC address, so the packet will be automatically discarded if it's not coming from the correct MAC address. Okay, right. So how this option in the preprocessor can provide some issues. Those guys, they had the following situation. They had a client, FTD. Then there was some routed environment here. And a server. Now, the problem was that after deploying FTD in the network, the connections or the throughput between the client and the server was very, very limited. So there was a slowness in the network, noticed slowness in the network. They first find out that they have around 50% of packets drop on the FTD. Okay? They get that number from some graphs. There are some statistical information, and you can put that on the graph, and you see how many packets are being dropped by the FTD. And they saw 50% of packets going through the FTD are being dropped. Okay? But they didn't notice anything in events, in the logs. Okay? There was nothing in the log, because at the first sight they saw that they thought that it might be the problem with IPS, basically. So maybe there is some signature that is dropping, right? And so there should be something in the log, in the events, in the intrusion events. But there was nothing. Okay? They just noticed that based on this graph, seeing that 50% of the traffic, half of the traffic is dropped. Now, after investigating the problem, they find out that the packets are being dropped by the TCP stream preprocessor. A TCP session hijack is responsible for that. And this preprocessor option is enabled, but the logging for that option is not enabled by default. Okay? So what was the problem? The problem was this: the client has some MAC address, right? So when there was a session going this way to the server, so FTD keeps the MAC address of the client. Then the returning packet went through this way. So FTD keeps the MAC address of this router, right? That should be still fine, but the problem is that someone decided or previously configured a per packet forwarding or routing on this router. Normally it is per session, right? So this one packet went this way to this router, one packet went this way. So exactly half of the traffic went through this way, half of the traffic was dropped. Right? That was the issue. Now, let me show you where is that setting. Remember, the network analysis policy, that's the place where we can configure preprocessors. But when we go to the policies, there is no option to see network analysis policy here because it's not there. You need to go to the access control policies, and here on the right hand you have a network analysis policy. There are a couple of options that looks like grayed out, but this is actually a clickable item. Network analysis policy. You click this, and guess what? Network analysis policies, the default ones, are again read-only, similar to the IPS. The default IPS settings are, or IPS policies are read-only. Same with network analysis policies. So I can create a new one. I'll give it a name like my preprocessor config, let's call it. Similar checkbox to inlay mode, to drop or not, and the base policy, because it's very similar to the intrusion policies. The difference is that in the intrusion policies, we have signatures. In the NAP, we have preprocessor configuration, right? So we need to inherit settings from one of the system provided policies. And notice, because those guys that I was talking about, in this example, they were using the default base policy, balance, security, and connectivity, because that's actually the default preprocessor config. So let me show you. If I use it as a base policy, I will show you what are the default settings for preprocessors in balance, security, and connectivity. Okay, notice on the left, we have preprocessors. We still have policy layers. If I click that, I have a built-in layer with some preprocessor config, my changes to change that, and the policy summary. The same thing like in the intrusion policy. If I click that settings, I'm going to see that the whole list of preprocessors in the system. So they are divided to different groups, like application layer preprocessors, like application layer, layer 7, right? So DNS, FTP, HTTP, right? Layer 7 protocol preprocessors. We have some SCADA preprocessors. So those are specially crafted preprocessors for industrial networking and industrial networking protocols. By the way, there is a special a firewall that Cisco provides for such environments. It is called ISA 3000, ISA, Industrial Security Appliance 3000, and it's based on the firepower, but it has a specially crafted preprocessors and signatures for such environments. Okay. Then the transport network layer, so layer 3, layer 4 preprocessors, including the IP defragmentation one, which is by default enabled, and some specific threat detection. And someone was asking in the chat today about how we can check if there is a port scan or some kind of thing like this. So here, the port scan detection, there is a preprocessor like that, which is by default disabled, but you can enable it. By the way, when you click enable, that preprocessor setting will be added to this list on the left. So let me click enabled next to the port scan detection, and this is going to be added here to the list. Okay, because if I want to see the settings for that preprocessor, I can click that on the list, or from here I can click on edit next to that preprocessor. Okay, so we can configure this preprocessor to check if someone is port scanning and stuff like that. Anyways, I would like to check the IP defragmentation first with you. Notice by default the policy for defragmentation is Windows, but this is the 7, 1, 2, 3, 4, 5, 6, 7, right? 7 different defragmentation policies. Okay, so depending on what is the target, we should adjust that on the fly. So I said the manually option is to add target. So here on the left, we have a target. I can click add and say, okay, you know what, 10.2.2.2, actually, this IP address is not Windows, it's a BSD. Not HP, but okay, BSD. Okay, the default, so everybody else will be doing Windows. This host will be doing BSD defragmentation. Okay, but obviously the best way to do that is to use adaptive profiles and use the host profile information. Okay, back to our issue and example, right? Session hijacking, TCP stream. The TCP stream configuration, there are many different options here. And by the way, Cisco normally says that you shouldn't touch those options if you don't really know what you're doing. Okay, so and I think the same. You shouldn't change, adjust, any of those options unless you really know what you're doing. And that requires you to have a deep knowledge about TCP, how TCP behaves, or HTTP if it comes to the HTTP preprocessor. Okay, so you better don't touch it. But I would like to show you a way how to be aware of what's going on, because sometimes you may have the thing like this, a situation like this, that some preprocessor is dropping packets, but you don't know what's going on. You don't know what's happening. Okay, so my goal here is to show you how to enable logging for specific preprocessor features or preprocessor settings. Okay, so let's say here we have TCP session hijacking, which is enabled by default. We have it grayed out, but if I check this, I can uncheck that. Okay. Anyways, this option is by default enabled, which means the preprocessor will be doing its job, will be dropping packets that are not having the correct MAC address. Okay. But okay, do I know that this is going to be logging or not? Let me show you that. Where to find a logging signature for that specific option, for this option in the preprocessor. To be honest, the best option to check that is to click help here. Believe me or not. If you click help, just click help. The help is contextual, which means it's gonna take you to the specific location. Right? Notice it took me to the configuring TCP stream preprocessing topic in the help. So I don't need to search through the help manually. I'm already in the correct place. Right? So I'm looking in the TCP stream preprocessing options. I click that, and I see all the options described. So all those things that you see in the preprocessor is described in the TCP stream preprocessing options in the help. So I'm looking in a TCP session hijacking. Here we go. See what it does. Detects TCP session hijacking by validating MAC address detected from both sides of TCP connection during the three-way handshake against subsequent packets received on that session. Okay, so it gives you a clue what it's doing. That's the first thing. But the most important thing is this. You can enable rules. signatures. Okay, 129 is a GID. Column 9 is a signature ID, and 129.10 to generate events. Okay. So what we need to do, we need to check if those two signatures are enabled or not. So I go to my intrusion policies. I will open that in a new tab. And to really make sure if that's enabled or not, let me create a test. Or okay, no, a new policy. IPS, or maybe okay, let's call it pre-proc logging. And I'm going to use the base policy of balance, security, and connectivity. So it's basically correlates with my balance, security, and connectivity preprocessor configuration, default configuration. Right? So it should see if those two signatures responsible for this option in the preprocessor are set to logging or not. So let's wait a bit to create that policy. Okay, let me go to the my changes, or I can go to the balance, security, and connectivity, the base, and I can find out, see the GID column. One is for regular signatures. I'm looking for 129. I can filter out, but I can go to the role content and specify GID 129 to search for. Right, showing it. Or I can go to the on the left to the preprocessors, and under the preprocessors I can find out the TCP stream, and that's going to show me the all TCP stream signatures which are having the GID 129. I'm looking for what signature numbers? 9 and 10, right? Based on the help. 9 and 10. One is called Stream 5 Session Hijacked Client. One is called Session Hijacked Server. So depending on the direction, right? Notice that what is the default setting for them? Disabled. Okay? That was exactly what those guys, poor guys, were experiencing. They had that default option in the preprocessor selected, enabled, but by default, this is not being logged. So they experienced to have 50% packet drop, but they haven't seen anything in the logs about it. Okay. So What do we need to do then to make that work? I would need to enable those two signatures. Okay, obviously I cannot do that here because I cannot select that because I'm on the base policy, which is read only. I need to go to the My Changes layer and select those two, change the state. Actually, it doesn't really matter if I change them to generate events or drop them generate events, because this is not the signature that is dropping the packet. Okay, even if I select generate events for those two signatures, okay, the packet still will be dropped because this is up to this setting in the preprocessor to drop the packet if packet is not compliant. Okay, signature is only to have an event. Now the question is where to apply this config of the preprocessors and this logging for the preprocessors. So let me save all that stuff. Preprocessor config and preprocessor logging. Yeah, as everything else, exactly in the access control policy. That's going to be the access control policy, right? Somewhere on the advanced tab, most likely. So in a second, I will go there and show you that. So I go to the access control policy. And on the advanced tab, there's a section called Network Analysis and Intrusion Policies. You know what? Let me do this. Let me take a screenshot of those settings and put that on the whiteboard. Okay. Okay, where to apply that? Notice this. When the packet is coming, it's going to the preprocessors, right? Then the security intelligence, SSL, security intelligence, access control policy. Access control policy then directs to a particular rule, and the rule says, okay, go to the IPS 1. On the rule 2, go to IPS number 2. Rule 3, go to IPS number 3, or whatever, right? So now the question is, if our preprocessor config is here, and this is where preprocessor is doing its job, the TCP session hijack, right? Means drop is dropping here. What about logging? Where you need to apply the logging? Is it, no, we have signatures and logging here, right? In the IPSS. Where do we apply the logging? And the answer is, we are not applying it in any of those IPS policies. We have a special policy to do that. Notice in the access control policy advanced tab, right? We have a network analysis and intrusion policies. And we have a default network analysis policy. So this setting is our preprocessor config. Our network analysis policy. This is the network analysis policy. But the logging for that policy is here. This is called intrusion policy used before access control rule is determined. Because this IPS policy that we apply here needs to be done here before access control policy rule is determined. So it's here, right? On the working for a preprocessors. And obviously, if we have a policy, IPS policy applied, we need to have variable set that is used by the signatures in that policy. Okay. Actually, there are two meaning of that policy. Remember, in the first lecture of firepower, I was telling you that if we, in case that we have a rule for a Facebook, right, that is using some application detectors, there can be some packets that will be allowed before actually the system detects the application. And then the rest of the packets for that session will hit the correct application-based access control policy rule, right? So the question is, those, let's say, 10 packets that we need to send through until we get the idea about the application. Are we still checking those packets with some IPS or something? The answer is yes. And this is exactly why this intrusion policy is here. This intrusion policy has two meanings: the preprocessor logging and to check those packets until application detection detects the app. Right, so that's the number one reason for that policy. Number two reason for that policy is the preprocessor logging. Okay, so normal signatures, normal snort signatures with a GID1 will be used for number one to basically check those packets, and preprocessor signatures gonna be used for preprocessor logging. You may ask, why is it so difficult and messed up? And the answer is because that's the historical issue. Because in the 5.4 version of the firepower, they decided to split preprocessor configuration from the IPS, and they created NAP, network analysis policies. Before 5.4, the preprocessor configuration was done in the intrusion policy, and obviously the logging was in the same place. And in 5.4, they taken the preprocessor configuration out of the intrusion policies, but the logging is still there because it's based on the signatures. So that's a little bit messy now. Right, so this is exactly what they have here, but you need to be careful. Let me show you something which might be quite shocking, I would say. The problem is, and I think this is a, okay, I shouldn't say this is a bug. It's again, this is a historical issue, and it's something that should be resolved, I believe. And you may not notice that because it all depends on when you're creating your policy. Let's say I'm going to create a new policy, new access control policy. I'm going to name it test 1. And normally, what I would do, I would create that policy with a default action intrusion prevention, IPS, right? Just to not block everything by default. So if I do that, then by default, network analysis policy, the default network analysis policy is balanced security and connectivity. Okay? So TCP session hijack is enabled, and intrusion policy used before access control rule is determined is also set to balance security and connectivity. And we know that the signatures responsible for this TCP session hijack are disabled here in this balance security and connectivity. So this is exactly what was the issue that those guys were having in their network. They didn't do anything wrong. They basically didn't know, about such things like preprocessors and their logging. Okay, so that's the one thing I wanted to show you. Another thing is, if you create a new policy, let's call it test 2, but instead of setting the default action as an intrusion prevention, you say, okay, everything that is not explicitly allowed should be blocked, right? So block all as a default action. Right, I have a block all traffic default action. If I go to the advanced, notice that the default network analysis policy, so preprocessor config, is still balanced security and connectivity, but the logging is no rule active, which means no logging whatsoever. Okay, so you need to be careful with that. And notice this, even if I go to my access control policy rules and I change my mind, okay, I say, yeah, okay, that it shouldn't be blocked. Let's use balance security and connectivity as a default rule, right? If I get back to the advanced, notice that this is still no rule active, which means you will never ever see any log related to the preprocessors. Okay, so that's something that you need to check in your environment. What you have here, you shouldn't have no rule active. You should have at least some policy here, like even some system provided like balance security and connectivity. Because otherwise, those 10 packets before application detector detects the application will not be checked against any signatures, and the logging for preprocessors is completely disabled. Right, so this is something that you should check. Right. So what is my recommendation? My recommendation for you guys, especially in the first deployment, is to enable logging for preprocessors to know about what's going on. I'm not saying that all logging for preprocessors should be always enabled. Okay, it's not true, because preprocessors are dropping anomalies, are dropping something that is not compliant, with a standard, or it's not compliant with our policy. So it's actually an anomaly. And the question is, do we need to know about those anomalies? Maybe we shouldn't really bother. So if there is an anomaly, let's drop it and forget. So that's okay if the system is up and running for some time. But in the first deployment, I would like to know exactly what's going on. Okay. So my recommendation is to you guys in the first deployment to go and change those settings, to create your own network analysis policy, maybe apply this config here, and to create your own intrusion policy, right? And enable in that intrusion policy all preprocessor related signatures, just in case, just to see if any preprocessor is dropping packets or not. Okay. You can later change that if everything is working smoothly and for a couple of weeks. You can go back and change this intrusion policy to something system provided. Okay. At least, I'm not saying that you need to change the network analysis policy. Okay. It must be still balance security and connectivity, but logging should be your own. You need to create your own user-created policy. Go there, find out all preprocessor-related signatures and enable them, and apply this policy here. Then you're going to see everything that is happening in this system. Save and deploy, obviously. Oh gosh. Yeah, I know that this is overwhelming, guys. Sorry about that, but yeah, I'm not trying to tell you everything about each preprocessor config, because I don't know that. If I really need to know that, I go to the documentation. But the real real knowledge about that is how to enable logging, to be aware what's going on. Right? That's my goal, to share that info with you. Okay, cool. So that would be, there's a question. How to configure automation of mapping between IIP and, okay, cool. Thanks for that. I was forgetting. Yeah, here, this is done automatically. See, this detection enhancement settings. We have adaptive profiles, and it's enabled by default. Right? The problem is that adaptive profiles are not being updated by default, which means that if you have that option enabled, the initial IP to OS database will be sent to the FTD, but any updates will not be sent to the FTD. So what you should do, you should actually enable profile updates and specify the interval. By default, it's 60 seconds. You can change that to, maybe to something really, maybe 1 hour or even more, right? And then you specify for what networks you would like to update that. So that's something that should be, I think, adjusted. But by default, the adaptive profiles will deliver that information for the first time. Yeah. Thanks for the question. I was, I meant to talk about this. Right. Okay, guys. Next thing for today is the SSL decryption. I would like to really go through it. I'm not sure. I think I will. Okay, maybe we'll see how it works. So let's. What time is it? Let's take a lunch break maybe now, right? And then we'll be. So let's take maybe 25 for lunch break. We finish a little bit earlier. 25 for lunch break, and then I will be talking about the SSL decryption. Okay, so see you there in 25. Okay, guys, let's continue. And the next topic for today I'd like to cover is, before we go to the SSL decryption, there's one thing I would like to talk about. So it's quite important and correlating with what we have covered so far. I would like to spend some time talking about the event logging and impact flags, and a little bit about the tuning of the IPS policy. So yeah, let's put that on the one slide, maybe, the events logging. That might not be understood correctly. So let's say we have that our flow, preprocessors again, security intelligence, and SSL encryption, the security intelligence again, the access control policy, and based on the access control policy rule, we send the packet to the IPS to the further inspection, or and to the file policy, right? And finally, the packet is out. Now, depending on which feature is dropping packet or doing something with the packet, we're gonna have a different log or different place where the event is in the system, right? So first off, in case of security intelligence, that's the obvious one. Security intelligence has a special security intelligence events, right? That's easy. Access control policy rule will create a connection event. Right? So if we enable logging on a per rule in the access control policy, that's going to create a connection event. The same is for SSL. Where's the SSL information if a session was decrypted or something? It's also in the connection event. Basically, that's the same event, but additional fields that we can see in that event. IPS, those events are generating intrusion, or signatures are generating intrusion events, right? The file policy, file or malware events. Remember, the malware events this is a subset of file events, right? Related to the malware. By the way, preprocessors, where the preprocessors are logging, right? We just talked about the preprocessor logging. Remember, signatures are meant to log event for a preprocessor option. So that's going to create an intrusion event. Right? So if we go to the system, okay, system is logged out. Let me relog to the live system. If I go to the intrusion events, we'll try to find out if there are some regular signatures and preprocessor related signatures in the log. So I go to Analysis, Intrusion Events. Okay, let's see. I see only regular signatures, and that's because of, in the parentheses you have a number, which is the GID, generator ID, then the signature number, and then there is a revision of that signature. So 1 means this is a regular signature. If we see something above 100, that means this is a preprocessor related log. Let's take a look at the next page. Maybe there's gonna be something. Oh, here we go. See 119. That's the preprocessor log. High client oversized dir. By the way, preprocessor logs in the name, they are always all uppercase, but that might be misleading a little bit. But anyways, 119, that's the preprocessor. 125, that's a preprocessor. 133, that's also preprocessor. Okay, so some preprocessor logs we see here as well. Yeah, and the most important thing that I wanted to share with you here, or even refresh that information, if you go to the connection events, we go to the connection events, show you that. Connection events. Okay, maybe I don't see that here, but there is a column reason. Right? If I see something in the reason, that means this particular event is a security related event. Okay? Remember, we don't need to log connection events if we don't need that info. All right, but in case that there is a security related event that's gonna create a connection event anyway. Okay, I don't see that, but maybe in my system. Okay, I just clicked the reason column to sort based on the reason. Notice that if I have a reason like file resume block, right? Those are the security related events. So you need to know that here, connection events. Security events like intrusion, security intelligence, file malware will log an event in connection events regardless of the logging option selected in the access control policy role. So if we have, even if we have on the access control policy role logging disabled, that's gonna create an event in the connection events anyway. Right? Even if per role we don't have a logging enabled. So here we have that. Right? This is the logging. So even if this logging is disabled, we don't really will not have a regular connection event based on that because logging is disabled. But if there is gonna be a security related event, you know, maybe because of this IPS that is assigned here, IPS will drop, the signature will drop a packet. That's gonna create an intrusion event and will create a connection event for that particular connection regardless, right? So let me put that security events. Example, intrusion, security intelligence, file or malware. Will log an event in connection events. Okay, regardless of logging option. In access control policy role. That's important to remember. Okay. Okay, now if it comes to the IPS again and the events that it's creating, we still have a lot of events. Even if we use firepower recommendations, we initially tuned our policy as far as we could, and now we still have some events. What we can do to maybe not limit, but to investigate those events, how we can guess which of these events are really, really important. Let me go back to the intrusion events. Right? By default, when you go there, you're going to see a view that is showing you individual signatures, okay, and how many times that signature hit, okay. Obviously, in this time frame that we have selected, which is by default 6 hours, but here it's a little bit different. This is looks like 1 hour something. Anyways, in order to see individual events, okay, we can either click this down arrow on the left, but that's going to show us only those 2 events. If I want to see all events, I can just click View All. Then that's going to create or put me in the view that I see all individual events. Okay, here we go. Obviously, inline result is dropped. That means this signature dropped the packet. Okay, but how can I really know if that was something important or not? Maybe not that important. There is a nice thing, a nice clue here, which is the impact flag. See the impact? There is a number, 1, 3, we have different numbers, 2. It can be a number between 0 and 4, actually. Okay, impact tells you how serious this attack was, and if you need to investigate that further or not necessarily. Okay, let me describe you that. That's pretty cool thing. Okay, so we have a couple of impact flags. We have impact flag number 1, which is red. That means it was an attack to a vulnerable host. How do we know that? We know that based on host profiles. We know what's on the host. We know what is the service this host is running. We know that there is a vulnerability and there was an attack to exploit that vulnerability. Hopefully, hope that we have the signature enabled for that one so we can protect, okay? So red is very, very important. If you see some red, number 1, impact flags, those require immediate investigation because you have an attack to a vulnerable host. You had that. Number 2 is orange, and that means an attack to an open port. Open port. Okay, so we don't know what is the service on that port. We don't know if the service is vulnerable or not, but the port is opened and there was an attack to that port or utilizing this port. So that's something that you need to investigate too. Impact flag 3, yellow, that means there was an attack to a closed port. Okay, so you usually don't need to investigate those things unless you have too much time. Okay. Number 4 is gray. Gray. And that means there is no host profile yet created. Okay. So you have network discovery for that particular host, but there is no host profile yet, which is, I think, extremely rare to see. Because the host profile is going to be created straight away if you see the very first packet. So it's extremely rare to see impact flag 4. But there is also impact flag 0. Okay? I don't think that there is a color assigned to it, but it's quite similar to 4. It's still saying there is no host profile. Okay, but because of the network discovery is not having this IP included. Okay, due to lack of network discovery for the host or network. Okay, so you can see zeros are possible, 4 highly unlikely, 3 a lot of them, 1 and 2 not that often. If you see a lot of reds or oranges, that's gonna be really difficult for you because you need to investigate those things further. Obviously, this is a demo system, so we see a lot of ones. We see the orange one as well. So, but this is just to show you that those things. But normally in a production, you shouldn't see too many ones and twos. Should be maybe, I don't know, no ones per day and maybe 3 twos per day, something like that, depending on the network, obviously, and the scale. But it shouldn't be too overwhelming. But that's gonna give you a clue which attacks or which events you should investigate further. Right? Once you investigating those, you can instead of looking in those logs all the time, you can alert yourself about something happening. And this is really cool thing too. When you go to the policies, under the actions here, we have alerts. Okay, and we can alert based on the impact flag for IPS, based on the discovery events for network discovery, based on disposition for AMP, and we can also create some kind of summary email to be sent to us maybe once a day to see what was the security related events from IPS. But first off, we need to create one of those 3 alert types. It can be either email or SNMP trap or syslog message. So obviously, if you want to notify yourself about something important, that's going to be the email, right? Notification. Let me put that real quick on the slide. Notifications. Okay, 3 types: email, SNMP trap, or syslog message. Right, and you can do that in a simple way. That means alerts. Okay, you can create an intrusion or create an alert based on an intrusion event based on impact flag, actually. And that's really cool. Let me show you that. I'm going to create an email alert, name email to myself, to something from FTD something, right? Plus a relay host and so on. And then I go to the impact flag alerts. And I say, I want to send an email to myself if there is impact flag event 1 and 2 in the system. Save it. Simple like that. Pretty cool, right? And simple. Another way to notify, or another reason to notify yourself, is the discovery event. I wouldn't use that too much because there are a lot of events, discovery events happening, so it's really not that important. Malware event, that's quite important. Let me show you this. So if you go to the anti-malware, advanced malware protection, you can go and say, please notify myself if there is a retrospective event. Remember retrospection? That was the change in the cloud, change disposition in the disposition. So previously it was unknown, now it's malware. So we need to know that. We need to know about it. Okay? So we can send an email if something like this happens, maybe to the guy that is responsible for managing endpoints, right? Because probably there was an infection and this host is infected and we need to take care of it. Okay, so retrospection. Another option is all network-based malware events. That's not really that important. I wouldn't send an email to myself because of that, but the retrospection event is very important to know about. Okay, and finally we have that option to send the IP, I call it IPS summary email. So simple way, or you can do that in a complex way. And the complex way is called correlation policy. Right? Now, let me just show you the correlation policy. So correlation policy, first off, it's something that is done 100% on the FMC, on the manager. It has nothing to do with a device. Device is not correlating anything. Device is just sending events, individual events to the FMC. And it's up to the FMC to correlate them further to notify yourself about something. Okay? It's based on the rules. Again. But the correlation policy it's a little bit different than a typical policy, because normally in the policy you have a rules, right, and some actions. Here in the correlation policy you still have that, but the rule body, let's say, rule constraints are not being created inside the policy. They are being created outside the policy. So you need to create a rule, let's say rule 1, outside of the policy, and this rule will be checking if intrusion event happened and I don't know, impact flag equals 1 and something else like country was China. That means you have impact 1 flag, impact 1 event from China, which might be really interesting, right? This is the correlation rule. Then you create another correlation rule using some other, conditions. Okay? And in the correlation policy, you are assigning those rules with something called a response. So rule and response. And the response can be an alert, say alert email to myself, okay? Or the response can be a remediation. For example, you're sending null route to the edge router, something like that. Okay. Again, alerts. We have 3 of them: email, trap, or syslog. Okay, but for remediation, we have some modules, because those are the actions. There are 4 modules by default implemented in the system. One is called iOS null route, that will allow you to send a null route or configure a null route on the edge router, for example, to black hole the traffic. Okay, number 2 is PX grid mitigation. That allows you to integrate with ICE, Cisco ICE PX grid, to disconnect someone from the network. Another one is Nmap scan. So you can initiate Nmap scan from FMC. And another one is set attribute. Right, there are attributes on a host profiles, like kind of labels. So you can set attribute on a host. For example, if something serious happens, you can set attribute called, I don't know, to investigate. And then you can use this attribute to create a report and have all to investigate hosts on that report, something like that. So either a remediation is the action or alert is the action in the correlation policy. Okay, so let me show real quick. If we go to the policies correlation, I'm going to create a new policy. Give it a name, my correlation. Okay, and save. Notice that there are no rules here. If I click add rule, I don't have any rules yet. I need to create them outside of the policy. That's why the next tab is saying rule management. And so I click create rule. Let's call it test. And if intrusion event occurs, and it meets the following conditions. So impact flag, if I select that, there's going to be additional field selected here to be selected, is 1. Oh, by the way, 4 is blue, not gray. 0 is gray. Okay. I need to adjust my drawing. This is gray. Gray. This is blue. Sorry, guys. I've never seen 4 actually in the life. Okay, get back to that. Right, so if the impact flag is red, and I'm going to add a condition. And logical end. And I know destination country not, but source country. Source country is China, or I can do that even better. If someone from outside of my country is attacking me, I can do is not, right? It's not like I don't know, United States. That means everybody from outside of US. Right? That might be important. You know, I can add some complex and so on. I can snooze that rule. Obviously, that's not. It's quite important if you expecting to have many events like this, right? So it's nice to snooze that rule for a couple of minutes, so it will not generate new events, every second. You can also add some inactive periods, so this rule is not working during that period, which is obviously not very common case. We can also add some connection tracker or user qualification, some additional sections here, so we can use that some additional conditions. A connection tracker is using traffic profiles, so we can, for example, see what is or build a baseline based on the traffic to a host, and then use this baseline to monitor what's going on with that host. For example, we can find out easily some DDoS connections to that host. Right. So once I have that rule, I can go back to my policy. My policy is not enabled yet, so see this slider here. I can edit that. And add a rule. Now I have my rule on the list, test, add, and the correlation policy is matching the rule and its response. By default, there are no responses, but anyways, even if there is no response, there's gonna be an event, correlation event created, okay? But I can add a response here, this strange looking icon here allows me to add a response. So for example, email to myself, that's going to be my response. Click that and save. Right. So if this correlation happens, then I'm going to have an email sent to myself. Also, a nice feature is the whitelisting here. The whitelist is like a host golden profile. So you can create an ideal profile for your host, and then you can match against that profile all the host profiles that you are creating. And if something is not compliant, then it's going to be automatically flagged in the host profile with exclamation mark. Okay. And you can create a new, maybe the name is not fortunate, whitelist. Okay. But when you are adding it, you have an option to survey the network, which means that you can get what you have from your host profiles, or you can skip to create like an empty profile, and then you need to click and create everything from the beginning. So in most cases, we just do the survey network for a specific host or specific subnet, or just for everybody. That will basically take all everything that I have in my host profiles, which is actually a lot. See, everything. So that's maybe not the best idea to do that, but I can obviously delete all those things. Can prevent this. So yeah, so that's the whitelisting, creating a kind of golden profile and monitor against that. So correlation policy gives you a lot of flexibility to use. The way I have created some back in time. I was presenting on a Cisco forum. I'm looking for it now. Presentation about this, the firepower. It was source fire at this. Anyways, deep dive. Here we go. Yeah, that was this is the old, 5 years ago. That was the Cisco forum. I was presenting the source fire deep dive, and you can find a lot of useful information here, like a traffic flow, preprocessors, and stuff like that. But also, let me go to this policy layers, information about how to build the policy layers that you can, there are some more advanced options here presented on the slides, and also a couple of nice examples for correlation policies, right? How to build the correlation rules. Right, so you can find them interesting. The remediation modules, I was adding some additional modules in addition to those that are by default in the system. So yeah, I can share that with you guys. Actually, it's on a Dropbox, but I can copy the link. Oh, thanks. Yeah, so actually that's the 1.1 version. I have 1.3. I'm not sure what the difference is, but maybe there is something different. So I can put that link for you guys. Copy Dropbox link. Oh, here we go. Thanks, Ed. Yeah. I can also put that link on our website, so you can download it later. Okay, cool. Next thing is SSL decryption. That's actually the last thing for today. Briefly, because I don't want to go into the SSL today, like how SSL works. That's going to be the lecture before remote access VPNs. We will go really deep into how SSL works, what are the certificates, how the certificate, what certificate provide, how it works, what is the PKI for, and all that stuff, right? So we're going to be talking about those things. So here in the SSL decryption, I would like to just briefly introduce the SSL decryption technology, but that's going to be enhanced later in the class. Okay. There are three things that SSL decryption provides on a firepower system. Number one is called resign, which means, as name implies exactly, when you have FTD and you are going out to the internet, the FTD can reassign your certificate. Actually, if you're going over HTTPS, right, the FTD will intercept that and connect the destination on behalf of the user, and the response will be also like proxied. Okay, I would like to on a high level, I would like to say a couple of things about that. This is not for URL filtering or HTTPS, okay, URL filtering. Not, okay? Why? Because HTTPS URL filtering works without SSL decryption. Okay? Notice that HTTPS URL filtering can use different or other information in the packets to filter based on the URL. You know that in the SSL, the URL is encrypted, right? We don't see it, but we have at least two other methods to see what is the FQDN or what is the destination server that the user is connecting to. Option number one is using the server certificate. Obviously, in the HTTPS, the server is sending us the certificate, right? And in that certificate, there is a common name or subject alternative name field that will give us a clue what we are connecting to. And the FTD can block that connection. The problem is when there is a wildcard like this. Right? There are some wildcard certificates out there that instead of having this certificate issued to the particular host like www.facebook.com, it is issued to star or the asterisk.facebook.com. So all hosts inside the facebook.com can use the same certificate, which is against the reason that certificates were created for against the rules, but that's much cheaper, and that's why they are using those. But the problem is with this, asterisk, this wildcard, because what if we are allowing user to go out to facebook.com itself, to the www.facebook.com, but we are not allowing the user to use, maybe games.facebook.com or chat.facebook.com. Then this is not possible to guess what is the host that we are connecting to, because host is using the wildcard certificate. Okay, so in this case, there is another way to do that called SNI. It's a server name indication. Let me put that somewhere here, SNI, server name indication. Okay, so this is a TLS 1.2 extension that should be supported by all modern web browsers. Okay, supported by all web browsers. Okay, and it's using an SSL client hello message to include information what the client is connecting to. So in this case, in the client hello, there's gonna be an SNI field saying, okay, the client is connecting to games.facebook.com, right? Even though in the server hello, because that's the server SSL, that's the SSL server hello message, right? So even if in the server hello message you got that certificate with *facebook.com, the wildcard, the client is connecting to the games Facebook.com, and you know that. So URL filtering on the FTD can use that, can check that field in the SSL client hello, which is basically the clear text information, and can limit or drop the packet or whatever, right? So resign, again, back to the SSL decryption, because without decrypting SSL, we can still provide URL filtering for HTTPS. That's my point here. Okay, so as I said, this is not for HTTPS URL filtering, but it's still useful because in case of user downloading files over HTTPS, right? Then you would like to use anti-malware protection to protect the user from being infected. So that's a valid point, to use resign SSL decryption to check files that are being downloaded over the HTTPS. And finally, to make security intelligence DNS/URL work. Security intelligence, DNS or URL work. Remember, this security intelligence is done as a step in the flow behind the SSL or after the SSL decryption. So that's important, right, to have it. So how does it work? A little bit deeper. I don't want to go, as I said, too deep, because we will be talking about SSL in much more details later in the class. Okay, but at least let me show you. You may not understand everything yet today, but you will. Okay, so we have a client and server and the FTD in between. So first off, we have a client hello, SSL client hello, right? We intercept that and the FTD is doing SSL client hello instead of the client, or basically on behalf of the client. Okay, and the response is SSL server hello message. In that message, we have a server certificate. Okay, and in that certificate, we're gonna have a SAN subject alternative name field like www.company.com. Okay, let's use maybe example. Okay, example.com, and we have a signature made by some CA, right? The public CA. That's the signature of that certificate. Now, this is also intercepted, and to the client, we send SSL server hello with a certificate where the SAN is still the same, okay, but the signature now is by FTD. Okay, so we see the clear text here. So it works like a proxy, kind of proxy for SSL. It's actually man-in-the-middle kind of attack for SSL, because we are terminating SSL and then re-instantiating the SSL to the server, and then we are changing the signature. The SAN is still the same, but the signature is done by the FTD. So for a client, in order to not see any warning in the web browser, the client should trust the FTD's certificate, okay? Or a certificate that issued the certificate for the FTD, if that's possible. I'm going to configure that in the lab, by the way, in a second. Okay, let me finish the theory first. Second option for SSL decryption is named known key. Right, known key is about this. When you have FTD and a DMZ host here, and you would like to, you have HTTPS traffic going to the DMZ host. So in this case, what you need to do, you need to copy or move the RSA keys plus certificate from this host to the FTD, because the FTD must terminate this HTTPS. Okay. The problem with that known key approach is that FTD is not providing SSL offload. What do I mean by this? Let me show you. If we have a client, FTD in between the client and the server, right? If the client sends the HTTPS, FTD can terminate that, see the clear HTTP here, and then needs to re-encrypt that and send it to the destination server. There is no way to send clear HTTP to the destination server. So this is not SSL offload. Okay, so the offload is not possible. So something like this. You have a HTTPS here and HTTP here. This is not possible. Okay, why? Because the FTD is a security device, and it must be certified to some security standards like FIPS. And those standards are saying that there is no, that the security device can decrypt traffic, but it should re-encrypt the traffic. The clear traffic cannot leave the device, basically, right? So it must re-encrypt the traffic. So the problem is when you're using, load balancers for SSL offload. So I think that the best approach is this. You have your firewall. It can be FTD. Okay, let me put that FTD. Right. Then you put your load balancer. Then you put your FTD again. Might be the same FTD. Okay, and then the server. So in this case, HTTPS is here. Is being terminated. This is the SSL offload. So the load balancer is terminating the HTTPS and then sending the HTTP to the destination server. And FTD, for the second time, is seeing the clear text packet. That's, I think this is the best approach. So you don't need to, in this situation, you don't need to enable SSL decryption on the FTD. Okay. If you would like to do that, though, as I said, you need to copy the RSA keys, private public key plus certificate from the server to the FTD, so the FTD can terminate the SSL and then re-encrypt that traffic and send it to the destination. There are actually two ways to do that. A is to copy RSA keys plus certificate, okay, from the server to FTD. And option number B is actually use self-signed. Certificate on FTD. Then the problem is that this is going to be warning to the user, right? So it can be a self-signed or even option number 3, use public CA provided certificate on FTD. Something like that. So option number C is actually pretty good, I think. Okay, that's the number 2, and there is also number 3 that a lot of people forget about, that we can use SSL decryption to simply control the behavior of the SSL. Okay, so it basically allows you controlling SSL setup based on some characteristics, or yeah. So allows controlling SSL setup based on some you can, during the SSL setup, you can block weak ciphers. Right, so if someone is using RC4, trying to use RC4 or DAS, right, things like that, you can block this during the SSL handshake. You can block expired certificate. Right, so user cannot set up a connection to someone that is providing expired certificate. You can block specific or old, usually old SSL versions, right, like version 1 or 2. You can also match based on any certificate field and drop it. Right? So that's pretty useful. Let me show you that configuration real quick, and that's gonna be end of today's class. Yeah, that's not my lab. There we go. So go to the policies, SSL. I'm gonna create a new policy. With a default action, do not decrypt. Okay, and it's based on the rules. Again, the default action is do not decrypt, which means that we will not decrypting and sending it further to the security intelligence, then to the access control policy, and so on. Okay, I'm going to create a new role, and the new role can have an action to not decrypt, block, monitor, or decrypt with resign or known key, depending on what scenario I have. Right, resign is for resigning the certificate, so user to the internet connectivity. Known key is the internet to the DMZ. So I'm providing the certificate terminating SSL like a server. Okay. I'm gonna do resign, but resign, notice that is requiring me to provide the certificate. So before I go into that, I need to go to the objects and create a certificate. I will create self-signed certificate because I don't have a CA here. Not yet, at least. We will use CA later in the lab. So I go to the PKI section in the objects. Okay, I can add certificate enrollment, so I can enroll for a certificate to a specific CA, or I can click internal certificates. Yeah, can I generate add internal certificate? I need to provide that. Okay, so let me do this enroll. So I'm gonna enroll for certificate, and from the options of time of enrollment, I will check the self-signed certificate. So I'm gonna create my own self-signed FTD self-signed certificate. Let's call it parameters FQDN. Let's do FTD lab local, IP address no, CN, FTD lab local as well, organizational unit lab, Micronics, that's the organization, state, California, I think it must be uppercase, countries, US, email, that's not that important, keys, RSA, default RSA. Okay, I'm gonna create those certification. That's safe. So that's gonna create a self-signed certificate for me. Okay. Now I can get back to the SSL policy and say the crypt HTTPS. Let's call it this way. So I click decrypt resign, and I'm gonna be using certificate. Come on. Come on. Why I'm not seeing the certificate? Let me refresh that. Really, I don't see that certificate. Why? Okay. Yeah, gotcha. That's because this certificate that I created is just a self-signed identity certificate. That's not the certificate that I need. I will delete that. I need the certificate that will be able to sign other certificates. I need to generate CA's certificate. Okay, FTD self CA, let's call it. US, LA, organization is Micronics. Organization is lab, common name, FTD lab local. Okay, let's check now. Okay, now I see it. Encrypt web, let's call it, with this certificate. right? That's gonna be working for all 10 networks going to ports HTTPS, the destination. Notice I can also specify some certificate, DN, distinguished name, certificate status, right? Cipher suit. I will add those in a second. So let's decrypt. Crypt web. I can also, it's a good practice to add an option to do not decrypt financial services. Do not decrypt and use maybe in this case URL category. Finance. And obviously that should be the first, so up. Okay, do not decrypt financial services, then decrypt anybody else. Would be nice to block weak ciphers. Okay, so then I go block with reset, go to the cipher suite, and from here I'm selecting some weak ciphers like RC4, null, all those stuff that are considered weak nowadays. Add. Okay, obviously that should be at the top of the list. I can also add something like block but certificates. Go to the certificate status if it's revoked, right, or self-signed or expired, right? That's what I considered bad certificate. I want to block that. Yeah, so things like that, and yeah, I can save this, and now go to the access control policy and apply this SSL policy to my access control policy. At the top of that policy, I have SSL policy. I click that none and change it to SSL policy. Save it and deploy. Yeah. That's gonna take a while to be deployed, I believe. Okay, so I'm gonna be testing by sending some HTTP traffic through the device. Some decrypting all web. It should be easy to test, except the financial. So let's see. Okay, let me go to the over HTTPS to something like CNN.com. CNN should be CNN. Gosh, stop that. Okay, so notice that there is no interruption here. It works normally. I don't have any message, any anything like that. Thanks for a message in the chat. Yeah, we need the break, right? You need a little bit of time to rest. Yeah, I know this is pretty intense, that class. Even though it's 16 meetings, that's still intense. Okay, anyway, it's connecting. If I take a look at the certificate, can I? Not very. Oh gosh, showing me. Yes, that's the. Yeah, guys, if I would like to cover really everything in those systems, all the features, interesting things, that would take us twice that time. Yeah. Okay. Thanks for that comment. So, yeah, if you guys still see it as a value, that's good for me. Thanks. Yes, actually, yes, because it all depends on how we when we start the next edition of that class. And actually, when we finish in June, there is a vacation time. So the next class starts in September, I think, something like that. So you will get an extra at least 1 month or so. Okay, I will keep it running for you. Yeah, but yeah, I tried, but this is really, I think, outside my powers. Okay, yeah, so that's it. So let's check out if I will connect to the same website. I think it's doing that from the cache. Let's do something else. Okay, sorry for this Polish language here, but I need to reinstall the web browser. But it's saying that this is not secure, right? You need to go and see the Mozilla MITM. This is man in the middle detected because of the certificate. If I click to see the certificate, come on, can we see it? I think it's because of I cannot see that. You know what? Let me open that in because this Mozilla, the web browser is the latest one. It's quite difficult to show you. Show me that certificate, please. I don't know. It's a new Mozilla that is not working good. Let's check if the Edge works better. Okay, as you can see, I have a proxy. It's saying invalid CA. And the problem is that the Cisco is using high security. It's going to be difficult to connect to the Cisco, but let's use CNN. Okay, if I view the certificate, it should tell me that now. See what is the issuer of that certificate? It's issued by the FTD Lab Local. So I have a re-signed certificate. Everything is still the same. The only difference is the issuer of that certificate and the signature of for that certificate. Everything else is exactly as it should be. Right. Okay, anyways, guys, I think this is it for today. I know that was overwhelming, plus those you know, additional 30 minutes or 45 minutes that we have problems at the beginning of the class. So yeah, let's call it a day. Okay, yeah, in the chat about the WebEx recordings. No, they're gonna be available because the thing is that it depends on how much space we have on the WebEx server, and it's usually the case that the WebEx recordings, the old recordings, are being deleted after a couple of months after the class ends. So no worries. Okay. Yeah. Okay, guys. Thank you very much. And remember, next week we don't have a class because of the Easter. So happy Easter. Spend time with your families, and see you next week after, right? Okay. Thank you very much, and yeah, take care. See you next time.